Okay. Nothing is working right now. Hold on. Hold on, real. Give me a second.
It was the camera.
Yeah, we moved. So you can see the lighting's wrong. The camera position's different. I'll show you in a second why that is. Let me just get everything moved over in a second. This is life. How's everyone doing tonight? First off, how are you doing? We can definitely have a chat while I'm getting set up here. Shoot, how do I get this stuff? I'm hoping I don't close all these windows. I'm just trying to get my little server set up so that my mouse can go over there. I'll have it set up in a second. Yay. Yeah, no, everything's definitely all good. A lot has changed with the room, so I actually have, and I'll just show you. Actually, hopefully I can get the camera back set up this way. But I have like the ultra wide up here, and I actually have two monitors below it, which means the camera can't go where it went before. And the reason why I'm struggling with this now is because we had to record something. See, look at that. I messed it all up now. We had to record something, so we moved the camera from its current location.
It looks wild.
Hold on.
I didn't even notice you had the monitor up there, too.
Yikes. All right, give me a second.
I'll just hold it the whole time. How about
No, just set it. Look, check this out. This is gonna be an even worse view. This is gonna be a much worse view.
No, this is good B-roll. I mean, good footage.
We're making all kinds of noise. The problem is I can't see if it's good or not. Is that better? All right, so now, unfortunately, you're gonna have to take a look at this. Yeah, you can see all the stuff that we have on the table. All right, now we're good, I guess. Good enough. Now, can you guys hear us? I'm sorry that this mic is in your way. I'll try to figure it out later. Maybe we'll move it to this side in a second. All right, so that's good. What you're seeing on the screen right now is just this little server. I can fix this really quick. I just got to make sure I have the right IP address really quick. 2.141. All right, that looks good. Able to connect. Sorry about this. Usually we get to do some kind of pre-show prep to make sure everything's right. Even the lighting's off. We broke one of the lights, just a mess. But we're trying to record this video for this FedEx grant thing, and nothing worked out. Nothing worked out how we thought it was going to work out. Life's hard, but we're all good. Everything's all good. 192.168.2.141 is my internal IP address. That looks good. Client's name is top-os. Let's stop this. Start it. Okay, well, it looks like we are working off of our laptop tonight. That's fine. All good. We're all good. Everything will work out just fine. So let me just move everything. Cool. Glad you could hear. All right. What is this going to mean? This is going to mean that we don't have easy access to a shared clipboard, but that's completely fine. Let me just do one more thing here. Displays. Let me just mirror them. Apply. All right. Now we're good to go. We'll minimize this. I don't know why this isn't working. Let me just check one more thing. Client name 2.141. 192.168.2.1. All right. Well, happy week. I guess we're in week, what are we, 7, 8? I think we're in week 8 or something, maybe 9 even. But I'm really excited about this week. This is Container Week. Container Week is one of the most fun weeks we have I love Container Week. This is actually Container 2 weeks. Last time it was Container Week, but this time we're doing 4 parts for containers because last time it just wasn't enough time. This time we're gonna have this class. Next class is going to be just dedicated to Docker itself, and then the next 2 weeks are going to be pertaining to container orchestration. So these are things like Docker Compose. If you've ever heard of Docker Compose, so we're going to be doing stuff with Docker Compose. We're going to be doing stuff with Kubernetes as well. Kubernetes is the really hot ticket item. The really hot ticket item that people are loving nowadays. So this is just all the stuff from that FedEx grant that we still have pulled up. But yeah, so we'll definitely be diving into a lot of that stuff as well. So this should be a fun 2 weeks specifically for the DevOps course. It is a little bit of a paradigm shift. I'm gonna move the camera a little bit, but it is a little bit of a paradigm shift. So don't feel confused if let's get that out of your way. Don't feel confused if you are used to if like this is a big shift from what we've done so far, and this is your first time kind of learning. You just learned how to kind of get things installed on a server. You just learned how to hop into AWS and do some stuff inside of EC2. Don't sweat it. Not a big deal. But we're gonna learn a new way of doing things a little bit today. So let me get you guys the slides because we do in fact have slides tonight, and I'll share you out that link. Actually, I'll need to pull up here. Oh, stream PC connected. What about? All right. Really quick. Let's grab that stuff for you. Get your link. How's everyone doing tonight? I had something to tell you guys. The fun. Well, Terrence is sitting here. You probably can't see Terrence behind me because of the vantage point. But Terrence says hello. If you guys want to say hello.
Barely can see.
Containers. I'm doing good. I'm doing really good actually. So I've reached the next stage in my weight loss journey, so I'm excited about that. I'm actually really I'm waiting for my body to crash today because I had a long weekend. I went to hang out with went to hang out with my family. My brother's I've said it before, but my brother's a coach University of Maryland, so their basketball team has been doing super well, so we got tickets to the game yesterday, and so like we were there for a long time. I stayed down with my parents. It was super nice, actually. Kind of nice, relaxing weekend. That's also some of the reasons why we're kind of rushing now. I kind of took some time this weekend to kind of just hang out with the people that I love, so that was all good. But no, things are going really well for me.
Did they win?
They did not win, unfortunately. The team they lost to was also a top 25 team.
Oh, wow.
I mean, they should have won. They played pretty bad. I wonder if it was because we were there. I wonder if we brought them terrible luck. But who knows? Oh yeah, always gotta play the chill hop background music. All right, shareable link for anyone. With the link, save, copy link. All right. There you go. There's a link to the slides. I'll pull up the slides now as well. And then we can hop straight into all of the stuff that we're going to be doing.
Perfect.
All right. Actually, I got to try this one more time. Where is, what's that thing called? It's called Synergy. I got to try to fix this one last time. Let's see if it works. 1. Ooh, 3.2. What is this? Slack. All right, cool. So it's back open. The connect. So we're in the right on the right Wi-Fi, and we have the right IP address. Oh, maybe we're not. 56.1. Hold on.
It's doing live debugging right now.
Now I'm really trying to get this to work so that I have connecting to. No, problem is I have 2 Ethernet. That's not it. Change it back one more time. If this doesn't work, we'll just keep moving. 2.141. This is what it was before. With name Pop OS. Hold on. I think another problem. I'm sorry for the live debugging session, especially because what time is it? Okay, 8:11. We got off to a little start. Oh, wait, no, it connected. Immediately disconnecting. Oh.
Yeah, I'm about to see how smart it is. About to fix it.
No.
Yep, 2 seconds.
All right. Not 2 seconds. Why is it? All right, that's dumb. I'm done messing with this for now. All right, let's get started on some Docker because we're gonna be pretty hands-on tonight. So, what's up, Efren? We're gonna be pretty hands-on tonight, so this should be pretty fun. Again, if you're new, sorry, the vantage point isn't usually like this. The view's a little off. We're changing around a bunch of stuff. So, containers, greatness can't be contained, or can it? You know what? Sorry again. I need to be able to, it's less awkward to look straight ahead. Even though you're right in my face.
Oh, that's perfect.
Zoom out a little bit. It's right in the way, the camera's right in the way, but it's much better. It makes a little more sense for it to be right here. So, containers, greatness can't be contained. Or can it? So let's talk about what containers are tonight. We're also going to talk a lot about what containers are not, because that is very important in terms of containers and what they do and what they're good for. So a lot of words as usual. We'll read it, then we will break it down. So it's a little loud. Linux containers, in short, contain applications in a way that keep them isolated from the host system. So we learned about host systems and the virtualization piece, which I'm on hypervisors and host systems and things like that. But it's a way to contain applications in a way that keeps them isolated from the host system that they run on. So break that piece down. It's going to run on a system as normal. So they do in fact run on a server. They always run on a server, but yeah, they run on a server, they run on a system, a host machine, but it keeps the application isolated away from that host machine. So containers allow a developer to package up an application with all of the parts that it needs, such as libraries and other dependencies, and ship it out all as one package. So for one, the first part you need to know is that containers are an isolated way to run an application. It's a way to isolate it from the host machine, and that containers allow a developer to package up the entire application into this nice little easy to use package that contains all the things that are necessary to run it and ship that all at once. So that's great because doing so adds these benefits. It makes sure that there's a consistent development and deployment experience. So because you are packaging up all the things that the application needs and shipping it all out together, it makes it so that you solve the problem of it runs on my machine, but I don't know why it's not running in production. I don't know why it's not running on yours, which is a common development paradigm. It's a common development problem. I'll raise this a bit.
Common development excuse.
It's also a common development excuse. There we go. That's much better to me. So why does that happen? So everyone's computers, everyone's host machine has all kinds of different things installed on it. If I were to do a PS to check what's running on my machine right now, or used my package manager, use dpkg or something to figure out what packages are installed locally on my host machine right now, they would probably be vastly different from yours. And so my host machine is this computer right here, the computer that you're looking at right here. If I were to take a look at what's running on here and what's installed on here, it would be very different from what's on your computer at home, especially if you have a Mac or something. And this can be true. This can be true in terms of systems in a development environment. So, your production machine may have different packages and things installed on it than your development machines. Your development machines may have, different versions of things. Maybe, you have an outdated version of something in production, and in your development environment, you've updated that version. But that can cause problems when you try to deploy the same code base to something that's using two different versions. It can cause problems. So containers kind of help with that problem. They give you a consistent deployment and development experience because they package up all of the things necessary to run it inside of a nice little container. It also, because of that isolation, it allows you to isolate certain things from the host system. It allows you to isolate applications from each other. So this has an added security benefit. Security is a big thing nowadays because everything's isolated and things don't just have access to other things by default. That is a big help as well. It allows for rapid development, and it's going to be easier to see this when it's in action, but it does allow for rapid development because, again, it's easier to again, I don't want to dive too far forward with all the things that we're going to be covering, but basically it allows for really anyone who's running Docker to be able to kind of share this code and for you to be able to build things on top of things. So it allows you to develop code much faster. They're very scalable. So containers are actually, they're relatively small, they're pretty small in comparison to a lot of other things. And they can be used in conjunction with each other. So it's very easy to scale up the amount of containers that you have, the size of them, etc., to meet the demands of the traffic that you have coming in. And then they're portable, cloud agnostic, OS agnostic. What does this mean? This just means that it doesn't matter. They're not specific to any cloud or any vendor, except for Docker itself. So as long as you have Docker installed, Docker works on pretty much all operating systems, Linux, Mac, Windows. And again, everyone, because it can work on any of those systems, as long as you have Docker installed on a machine, you can move that thing to another cloud provider, to another person's computer. As long as they're running at least the same version of Docker, you should see the same functionality. There are some caveats to that if you're using Windows, but just as a general thing, as long as you have the same version of Docker or newer, you should see the same consistent experience as the person who built whatever you're going to be looking at. So these are the main reasons why containers are great. And there are other containers besides Docker. I think we're going to talk about that in a second, but this is for containers as a whole rather than Docker itself. But again, if anyone asks you any questions about Docker, you can give them these answers. So I actually wish I had my iPad set up tonight to be able to draw this. Maybe we'll go to draw.io for this. So containers versus virtual machines. This is this can be a tough concept to understand. So these charts here, they make sense. I had to put them here. I had to put them here because they're a good reference and they make sense, I think, after you already understand containers. So it probably is going to make no sense to you even after I go over it in a second. But we'll try to revisit this slide later on and see if it makes a little bit more sense to you. And maybe if I try to do something on draw.io to draw an image or something, it may help as well. But on the left we have the architecture basically for a virtual machine. What's up, Monkey Chunky? Thank you for the sub. Welcome to the channel. Welcome to the family. So let me get some water in a second. On the left, we have our virtual machines. These are the things that we set up before VirtualBox, VMware. This is when we talked about hypervisors. You can see hypervisor right here. And the way things are kind of set up is you see at the bottom, we're going to start from the bottom. You can see at the bottom, they're talking about infrastructure. That infrastructure is the hardware that your stuff is running on. So imagine my computer right now, the computer that you're watching me run this stuff on. This is in fact that infrastructure they're talking about here. That's why they picture a laptop. That is why they picture, some servers, the cloud, but the actual hardware that your stuff is running on. So we're comfortable with that. And we know that on virtualized, virtual machines use something called a hypervisor. We learned about type 1 versus type 2 hypervisors. Again, that would be like the software VirtualBox, or that would be your VMware, or whatever application is installed to manage that connection between the host machine and creating these virtual machines is the hypervisor. And so on a virtual machine, you would have the server or the computer. You would have a host OS on here. Well, you have your hypervisor, then you have your guest OS. And this is specifically for a bare metal hypervisor. What's up, God of Wark 4? I like that name. Welcome. And I guess this is specifically for, a bare metal hypervisor. You got your hypervisor installed. Then you have your guest OSs here. So what is that guest OS? That guest OS is that Linux distribution that you installed. So if I were to start up a virtual machine, and I think, I have my VirtualBox here, these are some things I have installed. I don't know how this got this name right here, but I appreciate that, man. I have a Windows 10 installation here, and I have a Minikube thing and a Stream Linux installed. This is what we installed. We installed Ubuntu on here, or Pop OS. This is the operating system that's talking about here. Is your guest OS. So I could install, you saw there I had a Windows 10 installation. I had like 2 or 3 Linux installations. This is how this will work. And in each one of those, you would have your libraries and binaries installed for your application to run. So in my Windows VM, let's say I wanted to use Microsoft Word and all that stuff, I would need to install .NET and all the things that are necessary to make Microsoft Word run. So I would have an entire operating system here. And then I would have to have the little applications and tools and libraries also installed in that virtual machine to make sure that the application I want to run can run. And you'd have to do that for each of these operating systems. So the way containers work is a bit different. It cuts out an entire layer of cruft, I like to say. But you have your infrastructure here, and you have your operating system. So this is you can kind of think about it like your hypervisor, but this is your host operating system. So like right now I'm running Linux on this machine that we have here. And that is my operating system. If you're running Windows, if you're running Mac OS, those are your operating systems. We learned about operating systems in the OS concept section, so this shouldn't be super new to you. But as we have here, we have different operating systems installed, different guest operating systems. So, but over here, we do not. Over here, we have a container engine. So again, I just told you that there are more than one container engine. A lot of people know about Docker, but Docker is not the only container engine that's out there. But in our instance, this is going to be Docker. So Docker is installed on your operating system. So on your Linux installation, you would have Docker installed. And then you can see here, it cuts out this entire guest OS section here. And now you have, your libraries and binaries are packaged right up with your applications here. Same thing here. App 2 has got all of its libraries and binaries, and App 3. So you've cut out these entire host OS section or guest OS sections. Why is that good, and what benefit does that provide? For one, it provides a significant increase actually a significant reduction in overhead. What is overhead? Overhead are the amount of resources needed to run these things. So remember how we were setting up these guest OSs? I have to give, if I were to start up Windows 10 right now, Windows 10, the way that I have it set up right now, would end up utilizing 4 gigs of RAM, a couple of processors. It would take up a lot of resources on my system just to run that host OS, or that guest OS. It would take up a lot of resources on my system because containers do not have they don't work the same way. They do not need that underlying operating system, virtualized operating system. You get a lot of your that overhead is significantly reduced. So you get a lot more power from your system, where you have a lot more power available to you from your system. It basically has all of the power from the host system. It doesn't need to be shared amongst other virtual machines. Now, each of these things, once they run, do take up they take up some resources, but we don't have this guest OS working that way. So basically all the container engine does is it allows these applications, these packaged up applications, to run. And then it just provides some APIs for basically the container engines and the containers to talk back down to your host operating system. So Linux, Mac OS. So like Linux, we talked about the Linux kernel and that it basically runs off a kernel. And that this kernel is basically an engine. It allows your operating system to do the things that it does. And it basically just kind of creates these connections so that the containers know how to talk to that kernel. And this is where we're going to go to draw.io, because I think that the first time you see this image, it doesn't really make any sense. And so let's see if we can go to draw.io and maybe we can make a little more sense of
Even with
this.
software development, I definitely remember sharing virtual machine images just to get that kind of the same kind of paradigm that you get with containerization. Because before Docker and all that stuff, you had to make sure you were programming on a consistent environment.
Yep.
And we used to just pass along those little images.
Those VMs,
images, yeah.
probably using
VMware, I think.
Probably using VMware, but to build them, you're probably using like Vagrant or something to build those things.
That was crazy.
But yes, so we'll do a blank one really quick. Let's see here. All right, so every time I do this, I use a dumb example, but hopefully it still works. Today we're gonna, you guys know I love cars. This is the first time I told you guys that I love cars as much as I do. So imagine this is a virtual machine. I'm gonna tag this as a virtual machine. So a little bit smaller. I can give you more of these. Bigger space. All right, this is your VM. So, what's up, Mold Oneers? I'm sure that's way off, but welcome. Thank you for the follow. All right, so imagine this big box is your virtual machine. So imagine this is your server, and it's got a hypervisor on it. Let's say it's running VMware. Now, everything that you want to run on this, you have to install a host OS. So imagine actually now that imagine now that this entire operating system is a giant truck. Imagine this big box right here is a giant Tesla truck. I don't know. It's a big truck, and it can pull a lot of weight. It has a huge engine. It can tow a bunch of stuff. It's a big old dump truck, and you need that to carry the load that you're trying to handle. So let's say we have this dump truck. Virtual machines is basically like taking that giant dump truck, the engine and all, and it's basically saying, all right, out of this dump truck, every time you go ahead and I'm literally coming up with this off the top of my head right now. I do this every time. We'll try to break it down. But let's say each time you install a guest operating system, it's kind of like this. It's saying, all right, big giant dump truck with an engine that has 1,000 horsepower and 1,000 torque or something. I'm gonna go ahead and I'm gonna install Windows over here. I'm gonna install Linux here. I'm gonna install Linux here, and I'm gonna keep adding servers. And now every time I do this, each of these is pretty permanent. It's pretty permanent, and I have to carve out how much space each of these takes up, how many resources. So let's say this entire thing has 1,000 horsepower, and I give. Let me see if I can easily. Probably because it's in a box, I probably can't. But let's say each of these gets. Let's say the first thing gets, 150 of those horsepowers. Let's see if I can move this. Let's say that one gets 150 horsepower, and then this one gets 300. Etc. So imagine that I moved a different power amount to all of these. Again, there's a limited amount of space here. There's definitely a limited amount of space here. It has 1,000 horsepower total for the whole machine. As we, create these smaller vehicles out of this one giant vehicle that's going to run it, we got to divvy up the engine, and we have a limited amount of space, which is fine. These can all run themselves. They're all self-contained vehicles. They can do all the stuff. Great. But I've got to predefine those things, and they consume all these resources at a time. So once you kind of run out, which is fine. That's the same thing with anything that has a limited amount of resources. Once you run out, you kind of run out. But containers work a little bit differently. So imagine, again, this is also that same dump truck. It's got the huge engine. that's powering a bunch of stuff. I think we did this with a house before. Maybe the house makes a little more sense. I don't know. You no longer have to do this. You no longer have to, let's say we still want a vehicle that does certain things. We need to solve a problem here. We need our application to run these vehicles. These are entirely contained vehicles here. Now, instead, we don't actually have to run entire vehicles to get what we need to be done. Containers work a little bit differently. You do not need to, you can set limits, but all of the containers, instead of running off of their own guest operating system, instead of these applications running inside of these self-contained cars, they don't need that self-contained car, because the thing that they're running in, this giant dump truck, the dump truck's a car. The dump truck is a car. So maybe I'll put a car here. You got a bunch of little cars based off of that one big car. But because this is a car itself, because this whole entire thing is a big truck, it's got an engine, it's got all the things that you need, we can all just use that one big engine. We don't have to divvy it up. We don't have to divvy up to make smaller engines. We can just use one giant engine. So these containers all kind of have their own direct line to the kernel itself. So we don't need to divvy those things up. So instead of doing a bunch of cars like this, you would do things like, maybe I need 10 headlights. Maybe I don't need a whole car. I just need 10 headlights. So I could run 10 headlights off of, the engine and the battery that's here. And I could have, 5 radios and things like that. I could break it up and I could run only what I needed out of here. And I could add more as I needed. But instead of pre-divvying this up and separating out the space, separating out the resources between each of these full cars, which is a significant amount of overhead. Again, each time you do this, it actually there's actually more overhead that's taken than just this 150 horsepower, because your host operating system has to also manage those things. Containers are a lot smaller. They're not an entire car. Again, they can just be like the headlight. And because of that, they can move faster. They can be, you can get more of them. They're kind of speedier. And again, they're self-contained units of functionality of applications. So a headlight by itself is in fact a useful thing. A radio by itself is in fact a useful application. It's a useful thing. It does something for you. And we can use, the individual things. We can grab some seats. Maybe we have 30 people that we need to seat. So we're going to grab 30 different seats here. And they can all be fed basically by the singular kernel. They can all be fed by this one engine basically. And so that is a weird example, and that didn't work out as well as I thought it was going to work out, to be 100% honest with you. Well, you can also think about it with like houses. I think we did it with a house last time, and think about like an apartment building. An apartment building is kind of like virtual machines. You have a giant building, a giant place of dwelling that will be over here, and in each of those things, there are a bunch of apartments in there, right? Everyone gets their own apartment, and everyone's apartment has the same thing in it. Each apartment has its own self-contained unit of living. So every single apartment in that apartment building has a kitchen, and it has a bathroom, and it has a bedroom and a living room, things like that. But a lot of the times you're not using those things. We have all these bathrooms in here, but these bathrooms aren't being utilized at all times. And we have all these kitchens, but people are at work all day. Like they don't need, these kitchens don't need to be here all day. They're just taking up space, but they're there for whenever you need them. That's kind of how virtual machines are. Everything's set up, everything's there, everything's available for you. Containers, on the other hand, are more like a bunch of those same people. Instead of living in their own self-contained apartments, basically there's a place in there for them to grab. There's one big kitchen, and there's maybe one big bathroom, and they can go grab things. They can go grab these resources as needed. They can go use these things as needed. So now you don't have a bunch of unnecessary waste throughout the building, because people are kind of only using things when needed. If a bunch of people, you have a big kitchen, so if people, if you need to expand the space in the kitchen, you can do that. I don't know. It's kind of hard to make this work with like real life stuff, but yeah. Let's go with that for now. And again, maybe it'll make more sense once we get a little more hands-on with it. Pickup trucks versus semis for moving boxes. That's true. Yes. a virtual machine would be more like a semi truck for moving boxes, instead of just using some pickup trucks when you kind of need them. Very quick, a little more agile. They can get down the streets faster, way less overhead for sure. What would be the container engine in this analogy? So in the car analogy, the container engine itself is actually the infrastructure of the vehicle. So the engine and transmission is actually the container engine here, versus the hypervisor. The container engine plus operating system are pretty much synonymous with the hypervisor here. These two things work in conjunction. These two things kind of work in conjunction to do kind of what the hypervisor does. These two things provide that layer of isolation the same way that the hypervisor does. It's right now, at least, group these two things together as the kind of the hypervisor, and what you're really doing is you're removing this guest operating system here. And what that means is now you no longer, you've reduced your overhead significantly, and it also allows these things to move much faster, and you'll see those as we get a little bit farther. But again, weird analogy for sure. Bring the cloud to the masses, absolutely. Oh yeah, I come over there pretty often. I actually looked at the opposite way. Pickup trucks, you need an engine, gas, etc. for one or more boxes versus a semi, which can much more efficiently move boxes. But this is interesting because this gets into how how cars actually work. But the problem with a semi truck is the semi truck is overkill for most things. Semi trucks are great when you need to move a significant amount of boxes, but only when you need to move a significant amount of boxes, which is interesting. Semi trucks also take a lot of management to commandeer. You can't just go rent a semi truck. You have to basically call the right people, get that schedule a pickup time. You've got to have a loading bay for that for that semi truck to come and get these things. You got to have someone to load these things on. It's very heavy. It is a very heavy process. It can't be done quickly. Whereas pickup trucks, semi trucks versus pickup trucks, they both have the same pieces that make them run. They both have engines. They both have they have engines. They have transmissions. They have wheels and things like that. But with the pickup trucks, if you do need to make a quick run, if you do need to rent one, if you need to commandeer something to do a small task, a pickup truck is much more efficient to get that process done. It's going to cost you less than gas. It's going to be able to move faster. Again, it's going to be able to get places faster. Containers are very much like that. They're designed. You'll see that they're designed for. They're supposed to be designed to do one thing, ideally. Whereas, these virtual machines are designed to kind of take care of a bunch of stuff. So I don't know. Let's go with that for now. All right. So what are some other things besides Docker? I think it'll make more sense as we get into it. But container technologies, obviously we're using Docker over here on the right. LXC, which is Linux containers, have been available for a long time. Docker's not the first of container technologies. The timing was right, the ease of use, the interfaces that it added to be able to manage these things just kind of won people over. But it is not the only container technology. Rocket is another one. Rocket, I think, is a Core OS thing. You can check them out if you'd like. Most of the concepts apply. How you interact with them is different. But yeah, Docker is kind of the big one that people have been using. So Docker debuted to the public in 2013. So not crazy old. Like it's still relatively new in the tech landscape. Debuting to the public is one thing, but for rapid adoption or for adoption takes, a couple years. So it's relatively new actually. Version 1.0 was released in 2014. So it was kind of in its beta stages before that, alpha and beta stages. 1.0 was released in 2014. It is written in Go. We've talked about that a number of times. We talked about that being another reason why we did Go in the beginning. Terraform was written in Go. A bunch of other stuff that we're going to be using was written in Go. So that is great. So that means it's fast and it's performant. It runs on Linux, Windows, and Mac OS. There are some caveats again to running it on Windows. It used to be actually pretty difficult to run it on. If you're running it on Windows or Mac, they used to ship you something called the Docker Toolbox, which is still available, but it was basically just going to set you up a virtual machine and run it off of Linux, to be honest. And the mascot is a whale. Great to know. I actually don't know why it's a whale. I mean, I get the shipping containers thing, but like, I don't know why it's a whale. But and this is something that may add some. This may add some context to the whole pickup truck versus semi truck thing. Docker intro important notes. Containers are designed to run a single process. Now, they can run many more things in a single process, but they're designed to run a single process. And maybe we'll look up the average. There's an interesting chart on the average runtime of a container, which is very, very interesting. So we'll talk about what that means in a little bit. And containers are designed to be ephemeral. This is very important. What does ephemeral mean? We talked about this previously in terms of storage, but it means that it's not going to last. It's not persistent. It's not going to stick around. So they're not designed for you to do a bunch of stuff and save a bunch of data to it, kind of like a VM would be, kind of permanent. I can save all my stuff to it. Containers are not designed to do that at all. They're designed to be ephemeral. They're designed to do their job and really to die. I know it sounds a little morbid, but that is kind of what they were designed to do, which is very important to note. And that might set the stage a little bit as we're learning more and more. I actually didn't know either one of these things when I first started learning this, and that's why I found it to be very difficult in the beginning. That is, I used them exactly like virtual machines in the beginning, and it caused me tons of confusion, tons of issues. It was not a fun experience. I thought it was the dumbest application. I thought it was the stupidest piece of technology ever. But again, that is me not understanding the concepts of Docker. So take a little bit of time here, chew on that. Again, take in this slide. We're going to revisit this a little bit later. And maybe during that process, I'll think of something different. What's up, Coach Show? Welcome. Maybe I'll think of a better example of a real life kind of example of how this kind of works. What's important to know now is basically that containers do not need a separate guest operating system to run on top of. They just need a host operating system, container engine, and they can run. Also important, again, remember that they are packaged up libraries and binaries. And I actually wish in this chart they would have made this line a different color. I know they were trying to keep it in this stack, but on your guest OS, you have to install these things manually. You have to, these libraries and binaries, these are things that you install yourself to kind of support your application. Then you install your application on top. In containers, these things are packaged up. These things are packaged together, which makes them super duper nice. Any questions before we get on to the next piece? Let's see. Can the containers interact with each other? Absolutely. They can interact with each other. We are going to talk about that. Are we going to talk about that this time? Let's see. This time or next time, we're going to talk about that. We're definitely going to get to at least building some containers tonight. Let's see. We didn't look at this because we were doing all kinds of other stuff. We will not get into them interacting, but absolutely, containers can interact with each other. It's very important that they be able to, or else they would kind of be dumb. But yes, they can interact with each other for sure. Running things on Windows, they take away your geek card. That's fair. Also, it's worth noting, you can install. We'll get to the installation in a second. You can install this on Windows, no problem. Just be aware that if you are interfacing with someone who's using this not on Windows, one of the problems you'll run into is file pathing issues, because Windows and Linux file systems are different. But you probably don't have to worry about that right now. You should still be able to learn it if you're running Windows right now. So you don't want to run a guest OS in a container. That is that is an interesting question, because the paradigm that you're going to see, it's going to seem like we're running guest OS in a container when we are not actually running guest OS in a container, we are running, we're going to end up like, so there are containers that are going to be built off of like, there are Ubuntu containers and things that you can use. They aren't necessarily, they're not an operating system. What they are the libraries and binaries that you're used to inside of Ubuntu and that you're used to having available to you. Things like apt, the apt package manager, they are bundled up into this thing. So no, you aren't running a full operating system inside of these things. You're not. Servers should be cattle and not pets. Yes, I agree with you. It's a little bit morbid. I remember someone telling me like, that's pretty harsh, but yes, servers are easiest managed. Servers at scale are easiest managed when they are treated as cattle and not pets. What does that mean? And again, I know this sounds super crazy, not super crazy, but super morbid. I'm sorry for any vegans out there, but when a cow gets sick, as a part of, if I'm a farmer and a cow gets sick, it has a possibility of causing sickness to other cows. The overhead of it is actually pretty rough. What do? They kill the cow. They remove the sick cow from the equation. And that is something, because we can move so quickly now because of infrastructure as code, because of scalability. That is how we treat our stuff. And maybe there's a better example than cattle for that as well. But yeah, when servers are sick, instead of fixing them, you remove them. You find the problem, you can find the source of it, fix that, but you remove those sick servers rather than fixing them. And this containers kind of work the same way as well. But you'll hear people talk about that a lot. So I just want to throw that out there. Cows as code. Never had a bad feeling eating a steak. I like to think of them as a miniature server that already has an OS. That is completely fine that is a completely fine thing to think about them as. It is like that. But I do think it's important to know that they are not running an OS. They're actually interfacing with the Linux kernel that you have, again, with their libraries and binaries. But yeah. So you're telling us to start killing cows. I'm not telling you to start killing cows at all. I'm telling you to start killing servers. Instead of fixing them, I'm telling you to start killing them. Burgers out of unistack parts of the cow. I don't know. Maybe you should try the unsick part of the cow.
Don't even risk it.
I wouldn't actually. If someone reminds me at the end of this, I have a very interesting story about a cow. About a bull, actually. Very interesting story. Remind me at the end, because we have a lot of stuff to cover here. But someone write that down. Maybe set an alarm on your phone. I'll tell you guys a very interesting story about a bull. A real life story that applies to my life, specifically my life. All right, I'm going to be the grown up here and keep us moving. All right, so Docker terminology. This is where I'm going to start taking some notes here. It's important to distinguish the differences between the things that we're about to go over now. The first one is a Docker file. And actually, I think this might be the last slide. Yeah, this is the last slide, and we're going to hop into some stuff. So this is great. Docker file. What is a Docker file? Docker file is the configuration file that we're going to write to be able to create container images. You don't know what an image is yet, but Docker is not really, most people do not consider Docker as infrastructure as code. I do consider Docker to be infrastructure as code. Why? Because you define the way that you want your containers and your images to be through these configuration files, very similar to Terraform. And the way that you do that is through a Docker file. So it's interesting because Docker files work very differently from every other file type in the world. Every other file type is the name of the file dot extension. So a Python file is myapplication.py, or a Microsoft Word thing is my document dot whatever the word thing is. I forgot what the word. I don't know. Whatever the dot extension is, images are myimage.png. Docker files are backwards. It is the descriptor. It is Docker file dot the descriptor. So or it's just Docker file. You can leave it as just Docker file if you'd like. That works with a capital D. The D does need to be capital. I don't want to hear any D jokes right now. because we're on timeout. But no, Docker file, the D does need to be capitalized. But if you wanted to distinguish between your Docker files, if you had more than one, it would be dockerfile.nginx, dockerfile dot whatever my application name is, or whatever descriptor I would want, which is very interesting. I don't know why they decided to do that, but great. Maybe we can look into that a little bit more. So that's what a Docker file is. It is where you define what you want your container image to look like, and we're about to learn about an image. I trouble wrapping my head around it in the abstract. Then I playing with them helps. They made a lot more sense, I'm certain, as far as so yes, we will definitely, it does make more sense getting hands-on. I really struggled. And yes, they're make files. Oh, thank you. That makes sense. That makes a lot of sense. Got it. Cool. We're not gonna talk about make files because that's gonna confuse some people, but thank you, Hicks. Even if you didn't intend to just do that, you just added a lot of context behind everything that I just said, so that helps. Came in a little late. Can you explain the big picture here? What is Docker good for? Docker is good for isolating applications away from things and security. It's also good for scalability. They're small. Containers generally are small, and so they can scale up and scale down fast to meet demand. So they're good for scalability. It's also good for consistency. So because these things are done in code, they're built via this kind of infrastructure as code paradigm. You kind of describe your application. You not even describe it. You kind of build out your application in these files. And anyone who runs this image is going to get the same functionality. It doesn't change between them. So it's great for the development experience. It also makes for rapid development experiences because you don't have to really worry about dev environments and things like that. You can do that very quickly with Docker, and you're about to see that hands-on. So that's what a Docker file is. Image. This image and container are the things that people get confused the most, at least in my experience. So what is a container image? When you see the word or you hear the word image in reference to containers, I want you to think about a DVD. I want you to think about a DVD. And so an image is the singular saved version of the application that you described in your Docker file. So you're gonna write out what your image needs to look like in the Docker file, and then you're gonna build that Docker file, and it's gonna create an image. Again, this image is going to be the thing that all of your containers that you're going to use later are going to be based on. So again, an image is like, my favorite movie. I don't think I told you guys what my favorite movie is. You're going to learn a little bit more about me today. My favorite movie in the world is Cool Runnings, the inspirational story of the first Jamaican bobsled team. Imagine I got this copy of I get the copy of this DVD. It's burned to this CD. The image is actually burned. The image of the movie is actually burned to the CD. I can play this CD any number of times until it breaks. These images won't break, but I can put the CD in the DVD player and I can play it as many times as I want. So I can spin up many instances of this movie. Not at the same time, unfortunately, with DVDs, but I can watch this movie over and over again. That the image that's here, I have a singular image. I can use this to consume it many times. And that's kind of the same concept here. This image is the file that your containers are going to be based off of. And they can be used to deploy any number of containers, but there's one image, and there can be many versions of your image. We'll talk about image versioning and all that other stuff, but an image gets built and the image by itself does absolutely nothing. By itself, it doesn't do anything. Having an image is kind of useless. I'm going to show you guys some images that I have on my machine now, but you use those images to deploy containers. They basically tell how the application is going to run. So I'll stop there for a second. Does anyone have any question about the containers? I saw some chats. Let's see here. Getting late tonight, time to catch up. What's up, Ari Winokur? That was a comment about the name, but based on definition. Yep. It's like she's having the worst poop ever in that image. It does look like that a lot. And now I can't unsee it. Now I got to change it. ISO versus the CD. Yeah. So if anyone has burned an image, the ISO file. Oh yeah, that's actually pretty good. That's pretty good. The ISO file. So when we were going to install Linux, we downloaded an ISO file. So we downloaded a file that basically, let's see, documents. Do I have ISOs here? Downloads. Should be a CD. But let's say you want to install an operating system. It downloads these .iso files for you. And so if I wanted to install Ubuntu on my computer, I can download this one Ubuntu image. That ISO file is an image of Ubuntu. It's a file that has, the setup of Linux, of Ubuntu on it, the way it's configured and everything. And from that one thing, I can burn as many, USB sticks or as many CDs as I want. Or same thing if you were trying to burn movies or CDs or something. You download that one file, you have the one file, and then you can put that file on many disks, use that to create many CDs or whatever you want to create. This is the same kind of concept. Again, a singular image can deploy multiple containers, but that's the difference between an image and a container. A container is the running instance of the image. So use that image to deploy a container, and each individual instance of that running image is a container. And again, you can deploy millions and millions of these if you like. But yes, that is the difference between a container and an image. The image is kind of that file, that is one file, and a container is that thing kind of running, kind of kicked off. And again, that'll make a little bit more sense when we actually run it, but just you need to know that relationship, an image versus a container. Containers are run based off of images, kind of like when we got to the AWS section, and we were deploying those AMIs, those Amazon machine images. That image is just like that. It's kind of this precompiled definition of what's supposed to happen when you run it, and the container is the running instance of that thing. So that is something that you need to know. Cool. So tag. A tag is an identifying, pretty simple. This is kind of what a tag is for everything else. It's kind of like metadata, and it is an identifier for your image. A tag is specifically for your image. So if, again, we're talking about Cool Runnings, the movie's called Cool Runnings. A tag would be Cool Runnings. By default, the tag there is a default tag. The default tag is latest. Is the word latest. And so if you don't specify a tag, it'll get that by default. But a tag, again, is that metadata. It's actually part of the name, actually, of the image, which is really interesting. It gets added in as a name, but it's a descriptor for what that image is. So if I had Cool Runnings version 1, it might be Cool Runnings :v1, and that would be the tag. That :v1 is the tag. And again, by default, it's :latest. And we'll see that in a second. If I wanted to go to version 2, I'd give it a new tag of version 2. And then a registry. A registry, I think we went over, actually in here, I don't think we did anything with GitHub yet. You probably see me push stuff to GitHub, but I don't think we did an actual Git course yet. But a registry is a place, it's a repository for images. So this is another thing that makes Docker really great. We said Docker is really good at, you're able to kind of pass these things around, and if it works on my computer, it'll work on your computer. So what that means is there are places you can send your images to where other people can retrieve them. You or other people can retrieve them whenever you need them. And we'll talk about more definitely go over. There's way more terminology that we'll go over. These are kind of the important high level ones. But it's a repository for your images. And we're actually going to take a look at the biggest one right now. But that's what a registry is. It is a repository for images, a place that stores a bunch of different Docker images. You can have your own. It's interesting because registries are actually just another Docker container that sets up all your stuff. If you ever want to have a private one, it's actually just another Docker container, which is very interesting. But yeah, these are just a quick 5 things that are kind of the main pieces of Docker terminology. There's a lot more to get into tonight, and we're actually going to get hands-on right now with Docker, because Docker is, I think, easier learned hands-on than it is through stuff like this. So does Kube use Docker? Yes. So we're gonna talk about Kubernetes. Kubernetes can use Docker, and most of the time when people are referring to Kubernetes, it is they're using Docker as their backend. Kubernetes can actually use a number of container services as its kind of service provider, as its backend. But yes, it does in fact use Docker, and that is why we are learning Docker first, for sure. When should someone use Docker and when should they use Kubernetes? We're going to learn about that next week during the Kubernetes section, but Docker by itself, I'll give you a little bit of info on that now though, but Docker itself is actually a bit cumbersome to, so Docker itself is not scalable. By default, it's kind of not scalable. They've built in some tools to do that. That's what container orchestration is. So next week is actually the container orchestration week. A couple people have followed, but the sound is kind of messed up. So hello everybody who's followed. What's up, Div Mode? Someone followed before you. Welcome to the channel. Glad you're here. Glad to have you. But next week is container orchestration week. So we talked about these things being scalable. We talked about them being kind of small as well. Once you kind of learn tonight how we run these things, you'll start to see that, like, yeah, running 1 or 2 containers, 3 containers is great, but I told you that you could run millions of these things. Like, you yourself aren't going to run millions of these things, but it's commonplace for companies to run thousands and tens of thousands of containers. And how do you like manage that? Like, you'll see that Docker by default does not have an easy way of managing that. It kind of doesn't make any sense. You'll see what it's like to run a single container, and then you're like, well, how the heck do I run 10,000? Like, I got to do this 10,000 times? No, that's what these orchestrators are for. Orchestrators are really there to help you run containers at scale, to manage the connections between them, how many of them there are, worry about the health of them and things. You hire 10,000 people to do one each time. Sure, that works too. Amazon does have a service called Mechanical Turk, which you can hire people to do tedious tasks, just like that. So if you got to do that, you go ahead and do that.
There's actually people doing it.
Yeah.
Wow.
Yeah. Yep. You can. Yep. They'll hire people to click through stuff for you, all that stuff. Yeah. Docker management can be a problem. Yeah. Docker at all. Yeah. The management of Docker can be really cumbersome. Definitely cumbersome. 3 orchestrators at work. See, that's a lot. I've never had to run 3 orchestrators. HashiCorp, Nomad. How do you like Nomad, Thug Muffin? I checked it out for a little bit at a conference. It seemed cool, but I didn't have a need for it yet, so I didn't dive too deep into it. Oh, it's a marathon. That makes sense in Kubernetes. Yeah. Okay. I'm gonna check out Nomad. I like HashiCorp's products, so I usually try to give them a try. I'll check it out though. But yeah, things like Kubernetes are going to be overkill for almost everything you're going to be doing personally. Kubernetes is going to be overkill. There are simpler orchestrators. I'm going to show you guys a little bit about Docker Swarm. Docker Swarm actually comes, I think, with Docker by default, which is an orchestrator to kind of help you out with this. Something that Docker themselves have put out. Even though I don't love Swarm, it's gotten better over the years. But Docker Compose is probably the one that you're going to be messing with locally when you're just trying to learn this stuff. Docker Compose is pretty valuable. Smaller scale orchestrator, but an orchestrator nonetheless. So we're going to talk about that as well. All right, let's go ahead and let's get this installed. So we talk about a registry. First, I'm going to go to hub.docker.com and give you this. And I actually think if you do ! Docker, I think it'll give you nope, it won't give you anything. Okay. This is the registry that we're going to talk about Docker Hub in a second, only because it sucks. So I think they make you use, I think you have to, like, you used to didn't need a login to install Docker, but I think you do now. But for if you're using Ubuntu or something like that, there is going to be a package manage one there. So I actually already have it installed. But if you're on Ubuntu or something, you can in fact do get install. Usually it's going to give you a different package name. So I don't think it's Docker. I think it's like apt sudo. You guys see my, yeah, okay. I just want to make sure you guys can see my hands. Even though this is like a password only for this. I already have Docker installed on here, too newly installed. I'm not gonna install it this way, but you can install it this way, but it might mess up, the version might be old. Let's head over to the actual Docker installation page. If you don't wanna mess around with like a bunch of Linux commands, they give you a few Linux commands. All right, so if you use Google install Docker, it'll take you to some Docker documentation here. And I think Docker's documentation is decent. Not amazing, but I think it's decent. So for Mac and for Windows, it'll just give you an executable. You can click on this and it'll give you Docker Desktop, and it'll give you something you can click through to get it all installed, which is great. But for anyone on Linux, like myself, this will also, for anyone who's using the Windows subsystem for Linux, this will not work. This will not work in there for a number of reasons that I'm not gonna get into right now, but it does not work by default. There is a workaround where you can install the Windows version and get it to talk to Docker inside of the Windows subsystem, and it'll work for the most part, but it's cumbersome. I wouldn't do that. If I were you, if you're on Windows, one, you can only get Windows Docker Desktop if you have, I think you have to have the Windows 10 Pro, I believe. I don't know if that's still the case. It used to be the case. That you needed Pro. Yep, Pro or Enterprise or Education. But don't fret, that is not a blocker. There is Docker. I'll send you the link to this. Docker machine? No, not Docker machine. Toolbox. There is Docker Toolbox for Windows, so you can use this. This is also available for Mac. This will basically install it inside of a little VM for you, which is interesting. Legacy solution. Yeah, it's a legacy solution, but it still works. I can paste this in. You can look for Docker Toolbox. But yeah, so let's take a look at the installation real quick if you're trying to run through this, because I think it can be a little bit confusing when you're trying to install it. There are two versions. There is an enterprise version and a community version. You're gonna want the community, the free one, which is the community version. I think they're both free, but I think you can pay for extra support with the enterprise one. I also think the enterprise one only has access to, by default, like it's like I think you have to use these like special certified packages, these images, I think, or that used to be the case. I'm not sure if that's still the case, but yeah, to do this, it's gonna have you do an update first. So we've been used to doing that. Then you can go ahead and you can copy and paste this whole thing right here. This is gonna add the repo that's necessary to your computer. So feel free to run and do that. I'll give people a little bit of time to do that. You can go through and copy these things. Just copy and paste each of these things. I'll tell you where it'll get a little interesting. You can actually probably, yeah, just run all these things here. Actually, I wonder what will happen if I just run them again. I wonder if it'll update. I actually don't know. Actually, what version of Docker is on here? 1903.2. What is the newest version of Docker? Docker current version. Let's see. What? Oh, I guess it must have updated through my package manager, I guess. So 03.5, I have 03.2, whatever, that's fine. So I'm not gonna click through again. I don't think it'll cause any issues, but I'm not trying to fight with anything. But update, go ahead and copy this whole command. You don't have to copy it one by one. You can copy that whole command. You can copy this whole command here. And again, I'm specifically on the Debian one. Really, I should have been on the Ubuntu one. Yeah, for Ubuntu, you're gonna want this. Same thing though, very similar. It might have messed up during this piece, but yeah, you run these. It'll have you go ahead and add a specific repository. It might have messed up if you use the Debian one because of where it tries to pull your kind of release version. There's a lot of steps here, more steps than I thought. And to install it, once you get that stuff set up, you just, I'm gonna run through it. I don't want to cause any problems in case. I don't remember how I installed it, but I'm gonna run through it because.
Doing all those steps.
So if you're on a Mac, it's a click through installer. Yeah, if you're on a Mac, you can use brew to install it. This is specifically for Linux. I lied to you. I'm not. It's gonna break. It might break stuff. I don't feel like dealing with it later. So see if you can get it installed. Try to get it installed. Let us know if you're having any issues. But I'll give people just a few minutes to go ahead and get that installed. Once you do get it installed, it's interesting. On Mac, you should be fine. On Windows, you should be fine. The hard part about installing on Linux is you can probably get that part set up, but there are actually. Oh, I didn't even see this down here. It'll let you just download it and install it via DPKG. I would prefer. I mean, I think you should do that instead, to be honest. But once you get everything set up, there's a bunch. You can see there's just tons of other stuff. This is the hard part if you're installing this on Linux. This is the thing that's weird. Is the post install steps on Linux by default. If you install it, the executable won't be in your path. We talked about in the Linux section kind of how that path works. So you just got to do a little bit to set permissions and get this inside of your path. So if you install it and you hop over to your terminal and you type in Docker and you don't get some output like this, it says Docker not found. You need to go through and run these post installation steps. And again, tonight we're going to be hands-on, but I think tonight is fine if you don't have it set up by default. Like if you don't have it all set up, I think before next time we'll need it set up. I think you can still get all the concepts tonight without having it set up. So don't sweat it if you're like rushing to get it installed right now and trying to fight through all the stuff. Don't sweat that at all. But I'll give you a few minutes to go ahead and do that. MTurk. What is it? Oh, Mechanical Turk. Yeah. Yeah, so you can have, and it is for pennies. It really is. It's really cheap. You can have people doing menial tasks for pennies. You can also make some. I mean, I need you to go through and click through this thing.
Gotcha.
Yeah. So, you can make money doing it if you care about. There's stuff that's bigger than menial tasks, but like you can make money off of Mechanical Turk. I wouldn't spend my time doing it, but you can. Like if you're running hard times, like it's a way to make some money. Seems like it would be pretty boring for not enough money, a lot of your time, but not particularly difficult. But yes, we are doing Docker tonight. Okay. Yeah, WSL won't work, but Docker Toolbox is the workaround. Correct. WSL, it won't work. It won't work in WSL. Docker Toolbox is, in fact, the workaround. WSL will allow it to get installed. If you're one of those fancy people who are on the WSL 2 preview, it'll work for you. It will install. It will, in fact, install on WSL. It will not actually run anything. Why? Because the instance, so it'll work on WSL 2 because the new version of Windows is actually going to ship with an actual Linux kernel in it. So remember, that kernel is the thing that's the engine for the computer. Docker is interacting with that kernel. WSL by default does not have a full Linux kernel inside of it. It's like It's like this weird, like half-assed thing. It works, but like not for this. It's not out. It's not out publicly. It's out in beta. So if you go into your Windows and you do like the insider releases, you can get WSL2. It does scare me, but I do like that they're embracing it. I really do. But it's not officially out yet. But it's significantly faster. I was watching videos on it. I've checked it out. I've installed the preview version on another laptop that I have. It is significantly faster. And it has everything now, and Docker does work inside it. And that is the Docker was the one final thing. Docker's the one final thing from keeping me from using Windows as my number one. I do prefer Linux, but Windows would then have everything that I needed. All the operating systems have one major thing that I can't kind of live without. Windows, honestly, for Windows, it's simply Docker. Is the Docker Kubernetes, and like having to do that, like having to deal with that, is really annoying to me. Mac is just games. Like if Mac could get some games going, and I could build my own hardware, I would go Mac. And if Linux had some content creation software, some good content creation software, I know there's DaVinci Resolve, and I'm a DaVinci Resolve user, but they do not support anything but a weird version of CentOS. If they had content creation applications, that would be great. I would go full time there. But I saw Krita, not stable enough yet for my needs. Blender is, I guess, stable and works, but it is not ideal. It's not ideal at all. Run this horrible mess of CoreOS host, run the CoreOS container. Yeah. Ooh, wow. That is intense. Hey, but when you say things like that, like I have enough experience now to know that when you tell me things like that, like most of the time, not always, the path to getting to where you guys got, where you are doing that, usually was a path that almost had to be taken. You kind of make a misstep, and you have to make another misstep to respond, and then that leads 2 years down the line, you got to do something else. And I know how you can kind of get there, but I don't know. All right, I'll check out Blender. I'll check it out. It seemed very cumbersome to make that. That absolutely did not have to happen. I feel you. I'll check it out. I'll see. I'll see if I can make it work. Maybe I will. But cool. All right. So now I've given everyone their opportunity to get it installed. Once you get it installed, again, if you type in Docker and you get, the man pages, basically how to use it, you're good to go. And again, that can be super confusing, but we are going to hop into. Let me just again make sure I'm not going into what's next time. Cool. Anatomy of a Docker file. So we did Docker installation. So we're right here on the anatomy of a Docker file, and what a Docker file is. So let's go here. Let's give ourselves. Let's get into a folder. Remember last time? I think we consolidated. Maybe that was Python. Streams. Go. This is DevOps Bootcamp Jan 2020. All right. We're gonna make a Docker directory in here. All right, so we got a Docker directory here. Let's look at the anatomy of a Docker file. Let's look at the official documentation, and let's break this down. So, Docker file documentation, and I'll share this with you all. Docker file reference. Yes, this is going to be. Yes, this will be on YouTube. Everything should be. I still don't think I got last week's stuff up there either, but I know I got the week before stuff up there. This will be on YouTube. You can. There you go. If you need it, there's a playlist for just that. What's up, Guts? Welcome to the channel. Thank you for the follow. Docker. Oh man, I know you guys can't see me typing. I'm on my other desktop. I'm just. Whoa, this is. Okay, never mind. Why is it's on like dark mode on one of my computers and light mode on the other? All right, so check that out. That is that's the reference here for a Docker file. So we're going to talk about what Docker files look like, the different pieces you have available to you to kind of build them out. We're not going to go over everything that it has, but we're going to keep it pretty simple. We're gonna learn the basics of building an image and how you can do that yourself. So it talks about the usage here and the Docker build command. So we're going to write a Docker file. You write these Docker files, and then you build these Docker files into an image. And just to preface this, think about these Docker files. Honestly, in the beginning, think about them like little bash scripts almost. Like they really are kind of like little scripts to attain the state in which you would like to use. But yeah, you ever done it from scratch? Yeah, with the Go binary? Yes, I have. With a multi-stage build, I have. 88 Opus, appreciate it. Thank you for the 3-month sub. I really appreciate the support. You've always been part of the family, so thank you for continuing to be so. Oh, 6 months. 3-month streak, 6 months. That's awesome. Thank you. But yeah, they're kind of like right now. We did a whole bash scripting lab. They're kind of like little bash scripts right now. Just to think about, just conceptually think about them like that for now. We'll expand upon that, and you'll be able to break out of that paradigm. But yes, we're going to be using the Docker build command to build an image from a Docker file. It says and the context. Don't sweat all that right now. You don't need to know all the ins and outs. We want to get the different pieces. It's letting you know how to do the build, but we don't care about the build right now. We want to learn how. We just want to learn how we even start this. Like how do we start this? So, I actually thought this was going to have a better start, but all good. I just wanted to get to this works. Environment variables are supported by bunch of stuff here. All this stuff is important, but this is what I wanted to get to. In here, you can see here I'm about quarter of the way down the page, maybe closer to a third. I don't know. We'll get to our first H1 heading. This is from. This is the first thing that we're gonna do. So you have a couple of different main Docker file kind of commands available to you to be able to do certain things. From is the first one that we're going to talk about. What from allows you to do, it allows you to initialize a new build stage with a base image. So from Docker is kind of nice because you don't need to redo. What's up, evil dirtbag Dirth? Welcome to the channel. Yeah, welcome. But yes, there's a lot of words here about what the from line does. From just makes it so that you can use another image that's already been created as your base image. So you can say, hey, base everything that we're going to do after this, everything after this point in the Docker file, use this other image that's already been created as the base. So I'm gonna open up. We're gonna do everything in tandem. We're gonna open up a Docker file and we're gonna start building it, and we're gonna learn about a lot of different concepts, a whole bunch of different concepts while we're building it. What's up, FMO? Thank you again for the Twitch Prime sub. Appreciate it. Really appreciate it. You've been super supportive of the channel. I appreciate the love. All right, so let's create our Docker file real quick, and then I'll show you where you can find out, you're like, oh, you can base it off an image. What does that even mean? Where do I get that from? We're gonna talk about that. So we're just gonna vim a Docker file. Remember, it needs to be capital, and our Docker file can just be called Docker file. All right, so new file here, and the first command we have is from. So I'm gonna type in from. Wow, that's not what I wanted to do. All right, from. You can see it turns red. This is a keyword. This is definitely a keyword here. So from. Now, and again, it says we can set a base image, and I actually wonder where this goes. Oh, this goes to a glossary. This is nice, actually. Let me find this on here. Docker glossary. This is great. You all should definitely save this page. Send it. All right. Yes. Everything in here you don't need to know, but there will be a lot of stuff that I say or that you'll come across that you need to kind of look up in this glossary. But we talked about the Docker registry, and I said it was a repository of Docker images. If you go to hub.docker.com, you can create an account. I think you have to create an account now. I don't think you used to have to, but you have to. And this is kind of where, by default, this is where Docker images come from. You can use any publicly available Docker image by default. If you have access, you can use any private one, but that's great. What does that mean? That means that you actually don't have to, for your own purposes, you generally don't have to rebuild. Most things that you're going to want to use are probably already built for you. And if it doesn't have the functionality that you need, and you need to customize it for your own use, you don't need to build it from scratch. You can use one of these, you can use an image, and you can use that again as your base image. You can base what you build off of this publicly available image. And so that's what we can do here. So the Ubuntu official image, again, we're kind of just sticking to what we know, just to kind of add some context around things. But there is an Ubuntu image. I know I said that these aren't operating systems, which is true. This itself isn't an operating system. This is a Docker container. It's a container. It's a Docker image. I mean, not a container. Sorry about that. It is a Docker image that was built that contains the libraries and binaries that, again, that you're used to coming from Ubuntu, that you expect coming from Ubuntu. So that can be a little bit confusing. Sometimes. Like, I remember the first time I was seeing it, I was like, oh, like there is an operating system and I can install Nginx on top of Ubuntu. Yes, that is true. That is in fact true. You can do that, but let me show you this. This is an Nginx image. I could grab this Nginx image right now with this command over here, and I could run this Nginx image. We know that Nginx is a web server. It would spin up and it would run a container or however many I specified, and it would have Nginx, the Nginx process running on it. But if I click here, it should take me to GitHub. All of these things are built off of these Docker files, and so this is gonna look pretty confusing to you. You never seen anything. You never seen this. This is a Docker file, just an example of one. But you can see the first line is from. So the official Nginx container is actually built from a container that has all the tools related to Debian already installed on it. So it's based off of a Debian container. And again, we can do much of the same thing. So we're just going to create some kind of container built off of Ubuntu. We're just going to grab Ubuntu and we're going to build based off of that just because. So this container is called Ubuntu. You can tell by this over here and by the name up here. There are official Docker images, which this is one of them. There are also non-official Docker images, things that you may push. Up here, we're going to push one to the Docker Hub too. But what's up, Fadiza? Welcome. Can you link this GitHub? Yes. No. I can't by default because my little server between the two computers isn't running, so I have no way to send it. But if you go to hub.docker.com, you can even see the one for Ubuntu, and you click on like this, you can. Like you click on an image, any image that you want. Again, we're using Ubuntu right now. You click on Ubuntu, and then you click one of the tags. And it'll take you to that GitHub. Any of them work just fine. So this, you can see here, this is the entire Docker file for the full Ubuntu operating system. And again, it's not an operating system. So you can see here, it's really just a bunch of Linux commands, a bunch of echoes. You've seen echoes and a bunch of C copies and chmods. And so things that you've seen before, but don't quite make sense in context yet. So we're going to base off of this Ubuntu image. So they base off of Scratch. We'll look at Scratch in a second. Scratch is like a from scratch, like Linux thing, like machine. It's empty, but it gives you kind of enough Linux tools to start building off of. But we're not going to do that because we're going to have to install too many things. And we're going to say from Ubuntu. And this is already now a valid Docker file. I could build this thing and it would be great. We're going to talk about what that's going to do in a second, but we're going to go farther. We're going to actually build something out real quick. So you run almost a whole OS inside of the container. Yes, yeah, you can. I mean, you can run all the libraries and binaries you could if you wanted to. How much of the boot OS does it use? So basically, all it's doing, instead of having everything running inside of here, you don't need it to all the stuff to run inside this container. The Docker engine allows the container to reach out and use the kernel for all the other stuff that it needs. So you only need the things that are going to support the application that you're running. And again, these are really designed to run like one process. You can run as many as you want inside of it, but they're really designed to run one process. So you don't need all the extra stuff in here. You can put it in here, but you only should put into these things what you need. And yes, that'll make a little more sense in a second, but I'll show you how this works. Also, again, I told you that you'd probably be a bit surprised if you saw the average runtime, the average entire life cycle of a container. And basically it's this big graph, and we'll find it where starts at 0 seconds or 0 minutes or whatever, and the graph shoots way up. And saying that, most containers lifespans are like less than a minute. And then it drops off very sharply and kind of goes off like this because containers aren't designed, they're generally not designed to run. Again, they're ephemeral. We talked about them before. They don't persist things. They're cycled out pretty often. So they're not actually designed to run for an extended period of time. They can run indefinitely, but they're designed to, again, kind of be herded and used like cattle. So like, they kind of just do their job. So a lot of people write containers to perform one task. Maybe if I wanted to just run a script, maybe if I had a simple script to run, I could run it out of a Docker container instead. And it would just do that thing. Once the container completed its task, once it got back, an exit code, it would go ahead and it would die. That container would die. And next time it needed to run, that image would spin up a new container. A new container would be spun up of that image. And it would run till completion and it would die. It wouldn't be the same image running over and over again, which could be pretty interesting. And don't say these no questions are dumb. Keep asking as many questions as you want. Docker, again, can be difficult to kind of wrap your head around. Let's see. How do you do a Docker image that needs user input, like a remote API telling it what to change in the config? That's interesting. What's up, Diego? Thank you for the Twitch Prime sub. Appreciate the love there. But yes, that is a very interesting. We'll mess around with that. That's generally not how you would want to use a container. And there are better ways to do that. Remote API to tell it what to change in the config. That's very interesting. We'll talk about that. Crashed my PC 3 times. I'm sorry about that. Maybe we'll figure out something else from the Docker toolkit. So that from line is what you want to base your image off of. So you don't need to build everything out. If you want some tools, why would you want to do something like this instead of using that Scratch thing? Again, that Scratch one won't come with like the apt package manager or Yum or something. Those are tools that are installed inside of Linux. A Linux distribution, we talked about that, are just tools and libraries that are packaged up on top of a Linux kernel. That's the only thing that makes these distributions different, is the tools that are available to you. There's nothing special about a distribution except for the tools that were chosen to be shipped out with that distribution. The collection of tools that was created. Same thing here. If we were to use that Scratch container, we wouldn't have access to, again, things like apt or Yum to easily install stuff. So we would have to install them either by source or through some other method, so it can cause some problems or make it more difficult. So I say in the beginning, you should use a container that has the stuff that you're used to, again, like Ubuntu or like CentOS or something like that. All right, so the from thing is the first command kind of we're learning here. To be able to give to it. You can only have one from. Why can you only have one from? Because your container can only be based off of a single thing. You can't base it off of more than one thing. So from, that's the first things we have here, and it'll give us a bunch of stuff. All right, the next command that we have in here I actually don't know what these are called, so that's why I put it in quotes. They might be called commands. I don't know what they're called. I guess they're called commands. We'll talk about the importance of them. They're all capital. We'll talk about the importance of them in a little bit too. So next one is run. Run is simply going to run the command that you pass in. It'll execute any command. It says in a new layer. We'll talk about layers in a second. These are kind of they're not advanced Docker concepts, but they're good topics to know, and there's something to think about. You don't need to utilize them while you're learning, but there's something to be taken advantage of later. But a run command will simply execute what you say. So like a run command can be like echo hello world. And when it gets to this, when I'm building this image, it'll read this first line, it'll say from Ubuntu, and it'll go ahead and it'll go out and it'll grab all of the stuff that you need to use an Ubuntu image. It'll actually pull the Ubuntu image. Then it'll go ahead and add this part. It'll run during the build process. And this was a very difficult part for me to understand. These things are happening during the build process, not when the container runs or anything like that. These run commands happen during the build process. So the build process will go ahead and spit out hello world. Great. But it wouldn't do anything later. When I went to go run this container, it would not spit out hello world or anything like that. This is something it wants you to execute during the build process. So a run, generally, the first run is almost always like an apt update or something, like and an upgrade to make sure you have the latest stuff. And upgrade. So what is it going to do right now? Right now, what this would do is this would download the Ubuntu image. It will take that, and then based off of that Ubuntu image, it would take the default Ubuntu image, and then it would run this over top of it. The next thing we'll do is run an update and an upgrade. So it would basically kind of starts up a little container and does this thing and kind of saves it to an image. Basically, we'll talk about you can do that manually yourself. You can also build images manually, not in a Docker file. We'll talk about that as well, but don't sweat that right now. But you can have as many run commands as you want. I could have done the update here, and I could have done an upgrade here.
Any advantage?
Yes, so there are. Yes, and this is where the layers come in. So each time you see me do this run command, almost every time you see one of these like capitalized new kind of command statements, this is a new layer. What are layers? So layers are a method of they're essentially, at least for our understanding right now, they're essentially a layer of kind of cached information or saved information about something that occurred. So right now, this would have 3 different layers. All right. The Ubuntu image, when I go to download that, and actually I'll show you this. Again, we're doing everything real time, so don't be confused here. I'm gonna pull this Ubuntu image down locally to my computer. So to do that, I would do docker pull Ubuntu. And this will pull the Ubuntu image. Now check out what you see here on my screen. You see a couple of different things here. You see latest, it says pulling from library Ubuntu. Then you see this thing, it says pull complete. This thing, there's 4 of these. But we know we only pulled one thing. We know we only pulled one thing. So what Docker does it builds these layers based off of what is inside in the layers in these images based off of what is inside of your Docker file. So what this allows to happen is, I pull this. If I try to pull it again, nothing will happen because I already have all the latest stuff. But let's say someone made a change to the base image of Ubuntu, but let's say they made it like down low. They made it in the 3rd run command. You would only see the delta get pulled. So like, let's say they made it in this section, in the 3rd run command. Maybe this is a from, maybe this is a run, maybe this is a run. If they made it here, Docker would skip over these first 2. It would say, hey, I already got this. I already have the first 2 layers. I've already compiled the first 2 layers together. I'm only going to grab the one that changed. this paradigm allows you to do a lot of things. Some images are huge. This allows you to save time during build processes. Like if you have a bunch of dependencies that need to be installed, let's say you have to install 45 things for your application to run. Let's say you're doing some automatic building of this, and every time you want to build your application, it's got to install these 45 things. That can be very time consuming. What these layers allow it to do is, all right, if I run through the first time and I install it all at once, I'm going to keep this stuff cached in these layers. And next time you ask me to do it, I don't need to redo this stuff. Docker is going to do its best not to have to redo any work. And it will only change the things. It'll only update the things you changed. So layering is a little bit of an art. It will change, interestingly enough, generally it'll change the thing that you edited downwards. So it'll generally have to rerun everything that you did and downwards. So you want to watch how you break these things up. If you have a section of code that needs to be changed often, you should kind of watch where you put that into your build process, because that can be problematic. But again, that in itself is a full learning experience on how to use these properly. That's why generally you'll see people add in all the installation steps kind of in one line. And so you'll probably see stuff like this where you the paradigm of where you kind of, it's all one run command, but so you can tell it's like these extra things. I can do this, and like I can do something like this, like apt install like nginx or something. And so basically, the double ampersand is how we string commands together. But every time, this will be one single layer. All the stuff that's here is one single layer. And if I go to another run command, this will be a new layer. A little bit of a kind of an advanced Docker concept, and for beginner Docker users. But yeah, we'll throw that out there. So run is one that you can have. So you can run commands to do this. So you can see here that these are normal Linux commands here. These aren't special. I don't have to learn any special custom Docker stuff. I literally am setting up, because it is Linux. It is in fact Linux. So I'm setting up this image to be how I want it to be. So it needs to have the things. Again, we're packaging up the libraries in binary. So I need to make sure it has all the things that I need for something to run. And so that's what you would be doing here. You would be setting up, getting all the stuff that you need installed, etc. So run commands allow you to execute just any command. So I could also do like, I don't know, maybe I have a file that's in the home directory, or, after nginx is installed, maybe I want to copy the /etc/nginx/nginx.conf. Maybe I want to copy that to the home directory or something. I don't know why I want to do that, but maybe I want to do that. So I could do a run and copy that thing to here. So that's the run command. So we learned the from, which will set a base image. There can only be one from command. And we learn the run command, which will just execute any command that's passed after it. And again, this can be run as many times as you like. There is not a limit on the amount of run commands that you can run. So that's run. Read through there. There's some caveats with run in the way that you use run, but I think it's more fun to practice. We are going to talk about the CMD command. We're not going to talk about it yet. Label, we're not going to talk about label right now either. Maintainer used to be a thing. So you might see some Docker files that might say like Ubuntu, and then there will be a line right after it, which would have maintainer, and then it would just have like, I think it's in, I don't know, it's super weird, but it would be like someone's email. It's going to let you know who the maintainer was. But it's deprecated. You don't need to do that, but you may see it. It's just a little bit of metadata to talk about who the maintainer is. It doesn't actually doesn't really do anything. But yeah. We're going to come back to expose. Let's talk about env. So this running instance, a running instance of this image is going to be its own little running little Linux application. The same way that we have environment variables, we talked about environment variables in the Linux section. So things like $shell, which tells what my shell is, or like I could set an environment variable like name equals Aaron, and if I echo name is going to be Aaron. This is a variable that exists within my environment, my Linux environment. You can also set up these same environment variables inside of your container. So why would you want to do this? Maybe your application, the configuration from your application, you can use these as placeholders. You can basically set up set up ways for these things to be accessed inside of your thing. So maybe my application needs an environment variable called and maybe it needs an environment variable of name, and I want it to be equal to Aaron. You can set up these environment variables that way. I actually think you can do it like this or like this. I don't think it matters. Oh yeah, key value or key equals value. But yeah, you can see here, environment, my name. So if you need to set up any variables, if you need to set up, I don't know, anything for your application to consume, maybe, you remember we set up our Nginx configs for those different sites. Maybe we want to pass into this container what the file path is for where we want the files to go, or maybe we want to pass in the URL or something. You can set up environment variables if you need it. So we'll talk a little bit more about environment variables in a second. But an add command, the add and copy commands are the ones I want to go over next. But add and copy are how you get. Hello, you're on stream.
Hey, Bobby.
Oh no, you're not. I lied.
Definitely.
This is Miss Uplight.
Oh, yeah.
You see, I think you've seen her before during the last engineering panel. She was hanging out during the last engineering panel. But yeah, so the add command, how do you get stuff into your image? So basically, I can take things that are on my local machine, my host computer, and I can put them into this image. I can bake them into this image. How do I do it? I can do that with the add command. Work done. So add command will allow you to do that. And so it's kind of like source destination. So I could say, if there was a file on my local machine called maybe there's an image and it was like my image.png. I could copy this from my source to my destination on my server, which would be like home/pictures or something like that, if I wanted to. Why would you want to do something like this? This is where it gets kind of powerful. So let's say you see here in the run command, it looks like I'm trying to install Nginx on here. And by default, you remember Nginx will just show us that one page. But for us to like set this up for our own server, we had to add in some virtual host files that had our own custom configuration. You can take that configuration, get everything set up. Now you save it here, you stick it into your image, put it in the right place, and now when this runs, it can be completely set up by default. You don't need to build this inside, you don't need to log in and type it out and do that. You can copy necessary configuration files, necessary things that your application needs. You can copy them directly from your host machine into this image so that they're there for when it needs to be used, if you'd like. So add, copy does the same thing. There's a copy command that does the same thing. The difference between add and copy is add will allow you to get things from a web destination. So add will actually allow you to grab things from like a URL, pretty sure. Where's that copy? Or will copy allow you to do that? Let's find out real quick. Never remember. Pretty sure it's add. Copy. Almost 100% sure it's add. I'm just trying to see if they give you an example of it. But if not, we'll find an example in a second. But add instruction copies new files, directories, or remote files from URLs. So yes, add will allow you to do that. That's the difference. So you can use add when you want to copy, if you'd like. I think copy has a few smaller caveats, but you can do that. So we're going to use all these for real in a second, but you can also do, just to show you, just want to give some examples here.
Yeah, it's add.
What'd you say? Yeah, it's add, yeah. Slash pictures. So these both will work. But again, add allows you to do things from a web endpoint if you'd rather download them. So we'll do an example of that as well. And again, I'm going to show you guys how to do this. You can also set the permissions of the file once it gets on there. So we learned about users and groups. You can set those things by default. So again, you're configuring it just as you're really scripting out the same way as if you were going to write a script to do it yourself. Remember how we wrote that script for setting up Nginx, and we'll find that script. And actually, let's go ahead and we'll Dockerize that script tonight. That script that we were using. Let's see if we still have that locally. Actually, we can use it as a paradigm. Let's learn the other commands real quick, and then we're going to use that script as a little like tool for us to Dockerize that really quick, just so we can see how that works. All right, so add and copy are two that I wanted you to know. We're talking about entry point in a second. We're talking about entry point and CMD together. And maybe the only other thing that we need to know about tonight is expose. So we'll talk about volume on Tuesday. Now let's talk about user and work there. User, again, pretty simple. Instruction sets up the username or the group. You can set up a group as well. So user is one that you can have. I'm not going to use user right now, but just throwing it out there. Workdir is a good one. You might ask yourself, I didn't run any commands that are kind of confusing to where it matters that you're running them in the right place. But let's say I were to run like a ls command. If I just want to run an ls-la, where would that actually run at? Like where would that actually run? What workdir allows you to do, workdir allows you to set the working directory. So you could say something like /var/www/html. And that will basically tell this, hey, any subsequent commands from here on out, this is where you're going to run them from. This is going to be the base directory. Until you tell me otherwise, this is where I'm going to run these commands. So if I were to not put this here, I think this command will be running / by default. But yeah, workdir just tells your container or the image that's being built which directory you want to work out of. So not always necessary, but use it when necessary, when you need to tell it. So you can also do a run CD works as well. You can actually do like a run CD /
So workdir puts you in var www.html and it runs those commands afterwards?
The subsequent commands will be run basically out of that working directory. So if you need to download something and you don't want to specify the download location, a workdir will say, hey, when you run these commands, basically CD into this directory and run the commands, all the subsequent commands from there. So yes. So let me get to, so that's workdir. I'm gonna get to the last few commands really quick. Arg, we'll skip arg for tonight because there are a lot of these things, but I don't think we need anything else. We just need to we need expose for tonight, and then we'll talk about CMD and entry point. So expose. So one confusing thing, so we talked about how these things are good for isolation. Containers are great for isolation. When you run a container, by default, a container is just it's a contained application by default. So like by default, nothing can really access this thing that's running. You have to explicitly create the connections to it. So if I'm running something like Nginx, we know that Nginx operates over port 80 by default because it's a web server. It works over HTTP. Or HTTPS 443. So if I were to run, and I can pull an Nginx server, and I'll actually do that in a second. I can pull an Nginx image. I can run a container, and you'll see when I run it that you can see it running, but it won't be doing. I won't be able to access it. Like it won't be showing me any web pages or anything like that. And that's because we have to give it kind of routes. It's contained. Because it's a contained application, it's isolated. We have to give either create connections to and from it, or give it paths to pass along data. There's a few different ways we do that. The one that we're going to talk about tonight is expose. we know that we have to, if we want to expose a port, this is what we have to do. We have to do expose and tell it which port we want exposed. You can expose multiple ports, but we have to actively expose the ports that we want running. Not only do we have to expose ports, but we actually have to also map those ports to a host machine port. So we talked about how only one thing can be taking up a machine's port at a time. If I'm using my computer, instead of installing Nginx by default, if I'm running Nginx out of a container, it still has to be served over a port. We know it works over a port, over port 80. I have to basically take this container that's running, and I have to say, hey, port 80 from this container that's running, I need to expose port 80. I know you're a contained application, but I want you to go ahead and open up port 80 and make that available. And not only that, I have to take that port 80 and I have to map it to a port that's on my computer. So it's important to note that does not have to be port 80. I can map port 80 from the container to whatever port I have open on my host machine if I'd like. It does not need to be 80. They do not need to be mapped to the same port number, but I've got this contained thing. I basically expose a connection from it. And if I want to be able to use my machine to consume it, I have to connect it to a port that's on my main machine. And I think this is also an interesting concept. It's not necessary. It is not necessary. But if you want to use that, if you want to expose it from the host machine, you have to do exactly that. So that's what the expose command does. And again, we're going to see that in a second, be a little bit.
That's interesting. Because I've developed before web apps, and obviously I was hitting my localhost on my machine, but I don't remember seeing expose in a Docker file.
It was probably with the run command that you had, but expose was in there.
Okay.
But yes, it says, hey, go ahead and listen on specified network ports at runtime so you can specify those things. What's up, Unicorn Dev? Welcome to the channel. All right, so let's move a little bit faster. So these are kind of the things that you need to know. The last two things are CMD and command and entry point. For right now, I'm actually not going to talk about, unless we need to, I'm going to skip CMD and save that for next time because we're redoing a lot more hands-on Docker stuff. Entry point. Entry point will actually override these kind of CMD commands. There can only be one of each. There can only be one CMD. As with things like add and copy and stuff, there can be as many as you want. CMD, there can only be one. Entry point, there can only be one. They do work in tandem in certain ways. The connection between them is actually very interesting and can be confusing. That is why we're not going to go deep into either one with this much time left because they can be confusing. All we're going to say that entry point is for now. It's deeper than what I'm about to go into, but entry point is basically going to be what runs, what executes when your container started. So you go ahead and you execute this image. What is the I said they were designed to kind of run one process. What is the thing that executes when your container starts? It basically, you're telling it like, hey, when you start, what do I execute? And so they say it allows you to configure a container that will run as an executable. Again, it tells it what to execute when you run. You don't need an entry point. You can use a CMD. You don't need a CMD. You can use an entry point. You don't actually need either one, I don't think. I think you can work without either one. But there are some interesting caveats between them. Right now, for a while, you don't need to really know the difference. Yeah, you don't need to know the difference right now. I don't think. But they are related, and they determine how the container kind of starts, kind of how the processes get kicked off when it starts. And again, there can only be one of each. So now you can see, since we started putting the Nginx stuff in here, let's first take away, we're gonna take away all this stuff. We're gonna have it install Nginx, and we're not gonna have anything else in here. And I'm about to catch up on the entire chat in a second. All right, so how do you Once you have a Docker file finished, you write your Docker file. Again, it takes time to learn the things there. There aren't that many commands. You can really do everything you need to do with just a few most of the time. But it is just like a little script. But once you do get it worked out, to build it, you can just do Docker build. You give it a -t if you want to give it a name. I know it seems weird to give it a -t for name, but it's for tag. But the whole name is really a tag, to be honest. But let's see, Docker build. I think I could just do a dot. So let's talk about what I just did here. So the Docker build command is how you go ahead and kick off a build of Docker. And I did a dot. So you have to tell it where to build from. So my Docker file is right here. So I said dot. I could have specified my Docker file. Or if the Docker file was somewhere else, I would just put it in that path to wherever that was. But that's why I put the dot here. I have to tell it, hey, start building from right here. So let's break down the output that we're seeing here. Sending build context to Docker daemon. The context has to do with a few things, got to do with the files that are in this directory and a few other things, which is interesting. So if you have some unnecessary files in here, I've seen this take a long time because people had like SQL backups in the folder and stuff. It can be pretty interesting, but don't sweat that part right now. Just know this starts to match exactly what we did in our Docker file from Ubuntu. I already had Ubuntu downloaded, so it used this. So this is the first layer. It says step 1 of 2. We only have 2 things in our Docker file, so it's only going to do 2 steps. There's 1 layer, and here's the second layer right here. It says run the update and install everything, and let's see if it built. So you'll get the output from what happens when you actually run it. So it is actually kind of creating these things. It's actually running a container basically and executing these commands over top. And you can see here, we get to the end here and it says it installed, it returned a non-zero code. So this build actually didn't work. You do not have any interactivity by default when you're building these Docker files. So super common when you are building things and you're using package managers that you know are going to take. We had to do this with our script as well, but that take input. You're gonna have to pass in the -ys to say, yep, go ahead and do those things. We'll talk about that in a second too. But let's see if we build it and we see what happens here. We're talking about scripts in a second. So go through and it's going to build everything out. What's up, TV Josh? Welcome. Thank you for the follow. All right, let's get to these. Let's get to this chat. Let's see. Onions have layers. Onions do, in fact, have layers. Brazilian, I want to learn Python, but I have difficulties in studying alone, always focusing on. This week's slow to understand your answer. Thanks. All right, I'll try. I'll do my best. Also, yeah, so I don't know if you knew, Carlos, that I run a Python bootcamp on Mondays and Wednesdays. So tomorrow we'll actually be doing more Python stuff. Same thing on Wednesday. Amazon Mechanical Turk and have someone do Python for you for pennies. Block 7, you're addicted to Mechanical Turk already. Let's see. Okay, so if you were passing a key or password, can you enter a local machine environment variable to be passed to the container? So that's interesting. Yes, you can do that. You can do that. You can do that to get it passed to, you can pass along your machine's environment variable if you'd like. You can do that. There are other ways to make that happen as well, but yes, you can pass along your, we're actually going to do exactly that when we get to the Circle CI section. We get to the CI/CD section. We're going to be doing exactly that. We're going to be actually using containers to build our application, and we will be passing environment variables in as keys and things. You can do that. I do use Control R. Control R is reverse. I was just holding this for some reason. I'm using my laptop keyboard, which I don't usually use. I have a custom keyboard right here that I've just learned how to type on. But my little server to get between both of my computers is not really working right now. It's really annoying, like really annoying. -Y is to have silent installs, right? No. The -Y is to pass in a yes for any type of user input that is asked. So when you go ahead and install an application on Linux, it'll basically, if there's dependencies and things that need to be installed, it'll say, hey, I'm going to make these changes to the computer. Do you want me to continue? And you have to give it some user input. During these Docker builds, you do not have that option. You don't have there's no parameter to be able to put in user input. So the dash Y just passes in a yes to these commands. What's up, Nick Wan? I've learned again. I'll wait till, thank you for the raid. I think you can probably see me, but everyone else is probably inside of a little ad that that's not my fault. That is Twitch's fault. I'll let everyone kind of get in here. But what's up, Nick Wan? Thank you for the raid. Welcome to the channel. Just going over a little bit of Docker stuff tonight. Let's see. I'll give you a shout out and I'll add you as a friend. Cool. What's up, everyone, from Nick Wan's raid party? Hopefully you're done with your ad. I'm sorry the mic is right in your face. We ran into a lot of issues earlier. I have a whole new setup here, so I'm trying to I got to set everything back up. One of my lights broke. I've been going through it a little bit. Not really though. Really not really. But we're just learning a little bit of Docker stuff tonight. All right, so we built this container. We built this image. We actually didn't give this image a name. How do you check which images are available? Can your intern fix the light? Whenever he comes back, he can when I order a new bulb. We actually ordered a new bulb from Amazon, and Amazon shipped us it's a used bulb. Like, it has burn marks on it already. Really weird. So they're sending out a new one, but really weird. What's up, LaFlame954? Thank you for the follow. But let's learn some Docker commands. So we learned build. We learned Docker build when we want to build from a Docker file. So if I run a Docker build again, it actually makes no changes. Why doesn't it do a rebuild? It doesn't do a build because, again, these layers are a mechanism of caching, and it noticed there are no changes from the last time it ran. If there were, it would go ahead and do those things, but there are not. So it doesn't need to do anything. So you can see it doesn't actually rebuild, which is pretty nice actually. And you can utilize this to your advantage later. But what if you want to just see what images you have? I type in Docker images. I can go ahead and I can see what images I have available to me. So we know that we downloaded Ubuntu, the latest, and 9 days ago. So I already had that locally. This is not a new line. It's just, there we go. A little bit better. So what you can see here is you can see the repository. You can see basically the repository is basically the main name of the image. So you can see Ubuntu, you can see the tag. Remember I told you latest is the default tag. If you do not specify a tag, it will always try to pull or tag it the latest as the default tag. Each image gets its own ID, its own unique ID. It lets you know when it was last created and the size of it. So you can see these are relatively small. Ubuntu is the image is 2 gigs or something, probably bigger than that, maybe 4 gigs, I don't know. But you can see here that this is only 64 megabytes, so a lot smaller here, so not this crazy thing. What's also great about these layers are that even though this image is 64 megs, and even though you can see this was built 4 minutes ago, it says none and none, we did not give this build a name. We just said build this, we did not give it a name, so it did not give it a name by default. Even though this is 152 megabytes, it's not actually taking up 152 megabytes on my computer. Because I'm using this base Ubuntu image, it's actually using these layers, and then this has some other layers operating on top of it. So it's really nice because it will pull data that it needs from other images that you have. Like, these images all refer to a specific thing, and it can utilize those things to build what it needs. So it doesn't, these aren't taking up 200 and something megs worth of space. It's actually probably only taking a little bit more than this. So just something to be cognizant of there. That's why those layers are cool. If you're using similar images in between things, they will utilize the same layers. They can utilize the same layers. But these are all the images that I have installed on my machine locally. No one else. These are all local to my machine. So things that I've got, some of the stuff I built myself, traffic, I didn't build that myself, Python, MySQL, PHP, Nginx, Lambda, all that stuff. There's some stuff I built though. I built these things for work. And I think there's not a lot of images that I built on here, but cool. You can build them yourself, but this is the one that we built. So how do you give it a name though? Like how do you give it a name? The way that you give it a name is you use the build command, but you give it a -t, Docker build -t. Again, that's for your tag, and I can call this stream Nginx. And so this will give it the repository name, but it actually won't give it a tag. It's actually going to default to latest, I believe. But that's how you give it a name, and we'll build. And you can see here, it basically just did the same thing. It took that and it tagged it as stream Nginx latest. If I do a Docker images again, you can see now none is gone, and it's been replaced by this thing here. So we've successfully built our first container, or our first image. You'll hear me say that a lot. I messed up. We've built an image.
I want to hear the difference between a container and an image. If you haven't already done.
We talked about it, but I'll talk about it some more. But yes, we built our image, and so we could use this image if we wanted to go ahead and deploy a container. Spoiler alert, if we were to do that, actually, I'm gonna show you this right now. I do Docker run. So you're learning another Docker command on the fly right now. But if you run a Docker run, that's how you take an image and you run a container based off of it. So you do Docker run, and then you specify the image that you want. So the image, I want to stream Nginx. You do, if you don't specify a tag, it will use latest. But if I wanted to, like I could specify it myself, but I'm not going to. And this is the default of how you run things. Now, even though this is the command, Docker run, the name of the image, there's generally much more you're gonna have to do to make it run properly. But we'll go ahead and run this just to see what happens. And I run it, and it does something, and it kicks me back out to the command line. So what have we learned so far? We've learned how to build. We're using Docker build command. We've learned how to see what images we have after we build them with Docker images. Now, how do we see what Docker containers are running? So remember, containers are running instances of those images. It's almost like classes in coding. Like you instantiate the class. That's kind of what we're doing here. We've created a running instance of this image. So the way that you see those is you do Docker PS. I know that seems weird. You might say, why isn't it something like Docker container? Nope, it's just Docker PS. And so you run that, and it's kind of like running PS on your computer, and it shows you all the running Docker processes. So image are the classes. Yes, an image would be the class. An image would be the class itself, and the container that's running would be an instance of that class. So so bitwise, that's what it would be. And so you can see here, I do a Docker PS, and you see nothing here. Even though we ran a Docker run, there's no container running here. Remember I said Docker containers basically run their process. Once they get back a exit code, they will exit, they will die. To see all of your containers, ones that have died too, you pass in a -a, and this will show you containers that are alive and containers that are dead. And you see here I have a bunch of exited containers. You can see all exited. So you can see here, stream Nginx, make this even smaller so you can see this kind of match up a little bit. I know that's really small for you, but just to show you that there are different, the container ID is over here, and the image that we spun it up off of is here. Now, the name is weird. By default, I'll make this bigger again. By default, Docker will give your container a name. You can give your container a name if you'd like, but it'll generate a name for it. It'll basically take two words and just put them together. So we have heuristic Corona here, goofy Nother from another one I ran. They're kind of fun sometimes to kind of just see what it's going to name things, but you can name it yourself. And I can see when it was created, and I can see that it exited. You might say, all right, well, I saw that you installed Nginx. I might have expected that Nginx would stay up and run. There's more that you have to do to make that happen, because again, what did we tell this image to do? Take a look back at our Docker file. We told our image to base yourself off of Ubuntu and install these things on there. Great. That sounds excellent. So the image started up. We gave it nothing else. We gave it no commands. We gave it nothing. And so it died. Not died, it exited. It didn't die, it exited. It had nothing to do. It served its purpose in the world. So there's nothing else really for it to do. So, all right. So we're gonna get back out of here. We're actually gonna go take a look at the official Nginx image and take a look. We're gonna make a much simpler one, but let's take a look at the official Nginx image and take a look and see if we can see all the extra things that they did to make their thing run. And we'll also use their image and see if first we can get that to run successfully, and then we'll replicate and make ours easier. So let's break down what they did. They used Debian as their base image. So Debian is what Ubuntu is based off of. It is a Linux distribution, a little more stable. But yes, give it a label. We don't need a label. They set up some environment variables. So they have a version here, NJS version. I don't know if that's Node or what NJS is for. Package release. They just set up some simple variables. They set up some environment variables here. Great. They go through and they tell you what they're doing, creating an Nginx user and group first to be consistent throughout Docker variants. So they're basically setting up some users so that Nginx can run using these users. So a bunch of stuff here, a bunch of Linux commands. We're just going to go ahead and believe what they're telling us that they're doing. And then after that, they're just doing some configuration, not important to us right now. They're just doing some configuration of Nginx, getting Nginx installed and stuff here. All right, let's take a look. They have a run command here that's basically going to forward the logs, it says, to somewhere else. Now, here's one thing. Expose port 80, we talked about that. So they have to expose port 80 here. And this is probably why you haven't seen any expose commands, because the expose command could actually be higher up in the base image. Okay. If I used Nginx as a base image, I wouldn't have to expose this.
You wouldn't have to.
Correct. But then you see the CMD right here. So basically, this is going to be a command, and there can only be one of these, remember, that this gets executed with. This format might be a little bit weird to you, but basically, it's basically getting submitted with an Nginx-G-daemon off flag. Not important that you know what that means right now. Again, that's a Linux thing. That's a learning how to use Nginx thing. But this command is going to allow... This command is mostly going to allow you to run Nginx indefinitely. Because Nginx is a web server, it needs to be up and it needs to be available to accept connections. We talked about these containers being ephemeral, and to run their process and basically die, you can have them run for extended periods of time. So let's take a look at running their stuff.
That's one question.
Ask it.
That. With the command that you just showed me, that's the equivalent to just running like a regular in a terminal, right?
No.
Okay.
Kind of.
Why not just have all that in one quote, like one single quote? Why split it up in three different?
Great question. Quotes? So Terrence, if you couldn't hear, is asking. He's saying, "Hey, that command sounds like it's just a Linux command that you're running," which is both true and not true. And we'll pull the documentation back up. But the command is actually, it is a command that gets run, but it's not in the paradigm of building the image. It's a command that gets passed in and actually overrides some other things that go into a container for how this container starts up. And so let's pull back in here and I'll tell you why. There are some commands you could just put together. Not scratch, where was it? Fine.
Sorry guys, I'm really
no. It's a great. It's a great question. It really is a good question, and it can be confusing. It can be confusing because there's a weird paradigm between CMD again and entry point. Again, I told you there could only be one. If you list more than one, only the last one will take effect. So you can list more than one, but only one will work. Okay. The main purpose of CMD is to provide defaults for an executed container. So. The default execution kind of method. These are the defaults. They can be overridden by the entry point. you can actually specify an entry point when you run a container. We'll talk about that as well. But the reason why you can't do that is because these need to be passed in as parameters. This is the preferred form. I guess I've seen issues trying to just pass in the command as you know. Like there are some that you can, but I think when it's broken up into pieces like this, this works out better. And this is basically where there are spaces, to be honest. So it is weird. But yes, yeah. Again, that's why I said it's a little bit weird of a paradigm.
Probably readability too.
Yeah. So I actually pulled the official Nginx image, the one that we were looking at, the one that's on Docker Hub. This is the official Nginx image. And I can go Docker run Nginx. And it'll go ahead and it'll run the image that we just pulled. Maybe. Oh no, it does. Okay, so I forgot about that. So here's what happens. Here's why it didn't kick us back to anything. It looks like, it might look like your computer's frozen. But actually this is not going to show you anything. So like, you might be like, oh, it's working. I can go to localhost. So this is actually, you know what? This is probably Nginx actually running on my computer because this shouldn't actually work. Let's see. I might have just tricked you all. Invalid option stop. Oh, Nginx service Nginx stop. All right, so it shouldn't have given us anything. Be broke. Cool, it's broken. Right, so we're running the Nginx container. What's happening? Oh, we're running the Nginx container here. I know you're like, oh, it's broken. It's like trying to spin up. No, actually, if I do another Docker PS, because remember, how do we see what's running? Docker PS. It is in fact running. Nginx, it tells us the command that was entered. Remember, you saw that Nginx-G-daemon off thing. It was created about a minute ago. It's been up for about a minute. It's on port 80. And then it gives it a name, youthful something. Great, it's running, but it's not doing what we want. We're not seeing Nginx working on our local machine. Like, that's what we wanted to use it for. Super weird. Great. Two things. There are a bunch of parameters you can pass into a Docker run command. A lot of parameters you can pass in a Docker run command to extend it. You're almost never going to just run Docker run, almost ever. You're actually, after you learn Docker, you're probably actually never going to do these manually anyway. My recommendation is to use Docker Compose for anything local. But whatever, that aside, this runs this way right now. It didn't kick us back to a prompt because Docker by default, the process that's going to be kicked off with a Docker run command is it's not going to run as a daemon. It's not going to run daemonized. So it's not going to run as its own little process. So it ran. And it will run for as long, basically because Docker is made for this thing to kind of run and exit. It's basically running and it's saying, cool, I'm running this thing, and it's waiting for an exit command, which never comes because the command that's passed in here, the command that gets passed in here actually says, hey, go ahead and kick off Nginx and basically run that process kind of indefinitely. So we never get an exit code. All right, but like, what if we don't want to see this? Like, what if it's like, no, just run in the background. And now you can actually see, because I hit Control C, but in Docker PS, it's actually not running. Nginx is no longer running now. All I did was Control C out of this command. Yeah. It's actually not running anymore. But to get it to run indefinitely, you Docker run -D. So D will daemonize it for you, and I'll show you that in a second. But it'll go ahead and kick off right here, and it'll take me back. And so now this is just running in the background indefinitely. So -D is what you're going to need to do to make an application run indefinitely. Now, that is not a true statement out of the box. It's not just anything you add a -D to will just run. That's not true. The process has to actually support that. But that is how you would daemonize something. If you want something to run in the background and just to run indefinitely, add a -D, and that will do that. So if you do a Docker run dash dash help, it'll give you the options that you have available to you. Lots of stuff. I told you this can be interesting. Oh yeah, I forgot. It's actually detached and not daemonize. Whoever I learned this from originally told me that, and it made sense. Made sense in the paradigm, but runs it in the background and prints out the container ID. But that's essentially what a daemon kind of is, or demon, however you pronounce it. I say daemon, maybe it's demon. But there's a bunch of stuff here, and this is why we can't go through a ton of stuff. This is also why we've broken this down into a 4-parter this time instead of a 2-parter, because there was so much in this last time. We struggled. We struggled through anything because we haven't even learned how to properly run Nginx yet. So what are some of the other things that we need to do? We exposed the container port. So over here we can see Docker PS. We expose the container port. And port 80, but we're not seeing it locally. Remember, I said we have to expose it, then we have to connect it to a port that is on the machine. I'll show you how to do that in a second, but check this out. What happens if I run the docker run command again? What if I, oh no, what did I do? I saw those available. If I run it again, this spits out again. And then I can do Docker PS. And now there are 2 Nginxes running. Okay, interesting. If I do a Docker, if I do it again. And I have 3 instances. I have 3 instances of Nginx running locally now. Very quickly, I have these 3 instances. One, we already know that's not really possible for you to do if you just installed Nginx, because Nginx is going to consume a port. It's going to consume port 80, and only one thing can be running on a port at a time. And it's just not the way normal applications work. But we've deployed 3 instances of the Nginx image, 3 containers, and they all are exposing the port 80, but they're not conflicting because they're not actually using a system port. The container themselves is exposing that port, but it's not connected to anything, so it's fine that we do this, completely fine. So I got 3 running containers. I don't really need them running. How do you stop a container? Let's learn some more Docker commands real quick. So 2 things here. I can stop one by doing Docker stop. Then I can pass in either the name or the container ID. What's interesting about the container ID here is you only need to pass in enough unique characters so that it knows it's unique. So if I pass in just a 2 here, it will know and it will stop the right one. Yeah, it's pretty interesting.
That's pretty cool.
I actually learned this recently. If I do Docker PS, you can see there's only 2 running now, and this ID is gone. But you can use the name if you'd like, and you can see the names get cool. Condescending swirls and mystifying Heisenberg is all cool. It generates them in itself, Docker. So if you want to stop them, you can do that. But how do you see stop containers? PS-A, remember that's for all. The -A is for all. So running and stopped. And in here, I can see the one that I stopped is right here with the 2 mystifying Heisenbergers right here. So this is the important, this is something interesting to know about containers. Although they spin up and they die, they do remain on the system. That's why you can see them all here. Their remnants, everything do remain, which can be problematic. So they're not removed by default. So you have to clean them up later. Container and image cleanup can be a burden in itself, but you can do that.
I did do that before.
Yep. Yes.
Eat up your RAM.
And so to remove the container, I can do Docker RM. The name. Actually, I can't remove this. So interestingly enough, if this one's running. Oh, because I did a -A. Let's pull the one that's already dead. Is this one? It will not allow you to remove a running container. So that is important to note. That's what happened in the command I just ran. I tried to remove a container that was already running, and it said, nope, you can't remove a container that's already running. But I go ahead and I remove that container. That container is now gone. Great, all good. Now, also to note for images, if you want to remove an image from the system, like if I try to do Docker, the way that you remove an image is RMI, so remove image. So this is removing a container. Removing an image is RMI. If I try to remove the Nginx image, it would give me a conflict. It would say, hey, these containers are using this image. I can't be deleted yet. This works for both running containers and non-running containers. If you have a bunch of dead containers, you can't remove the image until you remove the containers that are referencing them. Why? Because you can actually restart images that have stopped. So let's say, I wouldn't do this, but you can do it if you need to. Let's say I want to Docker stop this booth one, admiring booth. I can also restart it. Great, and now it's back. I should have showed you that it was stopped, and it's back up. So we stop it again. Docker PS is down. Only one container left, and we can start it. So you can start and you can stop containers. That is important to know. It's important to know that when you do stop them, when they are stopped, they're not removed from the system. They are still there. It's also important to know that you cannot remove the image that's associated with them unless you remove both the started and stopped instances of that image. So any container that was based off of an image, they all have to be gone before you can remove an image.
They gotta be gone or stopped?
Gone.
Okay.
They gotta be gone.
Okay.
Watch. I'm pretty sure it's gone. I'm like, whenever people ask me questions like that, I know the answer, but you're making me second guess myself. So
I feel like I'm actually learning this stuff now.
Good.
This is great.
Docker stop. Docker stop 7. What? Oh, multiple IDs. There's only one thing running. That's fine. All right, so I stopped. There's no containers running right now, and if I do Docker RMI Nginx, we get an error because you got to remove all things. There are pretty simple commands to stick together to kind of purge and to kind of clean out different things, but we're not going to worry about that tonight. That's definitely for a Tuesday thing. It's going to be better for that when we're kind of just actually messing around and building stuff. So how do we get Nginx to map its exposed port to a port that's on our computer? The way that you do that is another flag. So remember in that run command, Docker run -d Nginx. So now we're gonna add in another -p. And so I could pass in a $P, and I think that it would automatically map port 80 that's running on the exposed ports that are on here to a random port on my computer.
Okay.
But usually you're gonna wanna specify which port that is. So actually we'll do the -p first, just so I can show you two different ones. Mm-hmm. If I run this, the -p a capital P is different from a lowercase p. And it lets you know right here. It's letting me know that port 80 on the container is actually mapped to port 32768 on my local machine. It picked that up by default. It'll pick a random port. And this can be useful. So if I try to refresh this will not work because this is trying to go over port 80, but the number that they were looking for here is 32768. 32768. Whoa, whoops. Localhost 32768. And you get your nice welcome to Nginx page. So application running inside of a container that we didn't have to do anything to get. Really, we just, instead of doing all the install steps and configure stuff, we just downloaded the thing and ran it. So that's great. But we can also do this. If we want to map it to a port that we care about, we give it a -p. We give it the containers port and the port that we want to map to. So actually, I don't know which one's which. I actually think this one is your host port, is your computer's port that you wanted to map to. I think this one's the host, the container port. We'll check in a second. But this will map port 80 on the container to port 80 on my machine.
Gotcha.
So I'll run this. Under Docker PS, and we can see now here 80 is mapped to 80. So now if I just go to localhost here in a new tab, I have two running versions of Nginx on my computer right now. I have two running versions on my computer right now. So the first one's system port. Let's do a third one. let's map it to port 90. And so now we have another one on port 90. And so now I have I have 3 versions of Nginx running on 3 different ports. And so that refreshed. Why is this good? This can be good, especially for development purposes, because again, you can't have 2 things consuming the same port. So this is actually a way for you to run many instances of an application kind of on the same machine. So that can be good. I've seen people use, this paradigm to run dev, like staging and prod off of one machine, really just running 3 different containers. So there's a lot of use cases for this, which is really nice. The -P is kind of nice because it'll pick a random port and you don't get any port overlaps and stuff, but it's kind of weird. So that can be interesting. So we'll stop there for a second because that's a lot. I'll answer some of the questions that have come up because I know we've gone over a lot very fast, very confusing, but we still have more to go over. So yes. Let's see. So how do you see it running? So that was a Docker PS. So that pull command literally pulled it from the main site. Yes. That Docker pull command pulled it from hub.docker.com. Hub.docker.com. So when I did Docker pull Nginx, it pulled from this. So what happens is Nginx basically uploads this to Docker Hub, this Docker file, and it gets built. It builds an image. It sets up those, it builds out, it sets up those different layers. Each of these things is a layer, and it gets into this registry. And in this registry is how you get it. So any of you can do Docker pull Nginx, and you will get the exact same thing that I got. It also tells you how to use it below, but I didn't want to show you that because then you would have all the answers that I was going to tell you, and it would be without context. But exposing external ports and stuff, I know it's really tiny. But yeah, exposing an external port, you can see here, they had it in the -D. You can see they put the -D, the -P here, and mapped it to a different port. So you can do that as well. But also note, this is just like anything else. I couldn't remap another version of Nginx to that same port. I'll try to remap one to 90, it'll fail because port 90 is already being used up. So no big deal there. So that's great. That is excellent, all fine and dandy. But what if let's say I wanted to build something off of this, but I wanted to learn more about it and I wanted to see what to do with this. You can actually log into most, if your container, if that image has a shell on it, you can actually log in and you can mess around and have some fun.
I do that sometimes.
And so this is good for troubleshooting. This is good for learning how to do this stuff. Let's say I want to log into the Nginx that's running on port 90. You take the name here, and we're learning about something new that we weren't supposed to learn until next time, but it'll be fun. We have a little, figure we're going to 11. You can do something called Docker execing.
I remember that.
Now, you got to pass some flags to this. These flags take a long time to learn. So Google, write stuff down. It takes a while to learn. So you have to pass in a -I for interactive mode. That allows you to be able to interact with this container, pass commands to it, and for it to give you stuff back. But you also have to pass in a T, which is for a TTY, which is, I think, stands for teletype, which allows you to type inside of it. So if you didn't do a -T, your keyboard would not be able to be used inside of this container, which is super interesting. But you do Docker exec and then the container ID or the name. Then you have to tell it which shell you want to use. We're used to using Bash. Most of them are going to have Bash. And it takes me into that container. So if I can do ls here, I can go into /var www. Maybe I can't. So you're not going to have all the commands available to you. That you're not going to see any colors because it doesn't have all of those cool things that you need. It has the bare minimum of things. This is a basic Bash installation. Okay, I actually have no idea where. Let's go to /etsy. I want to see where this site is located. /Nginx.
We do this all the time. We log into our application, all CLI commands.
Cat. See, I don't have a Vim. I don't have VI. I don't even think I have Nano. I would have to install all these things. You can install these things in here, but this is important. If I were to install Vim or Nano in here, that would only install it in this running instance. These are ephemeral. it would only install it in this running instance. It would not add it to the image. No other running instance of this Nginx would have Nano or Vim installed. So again, they're very isolated. That's very confusing for people sometimes. They're like, I logged in and I installed it. Yeah, you did, but that did nothing. That you installed it in one running instance. When this instance dies, it goes away. That stuff does not get saved.
If I wanted to have VI or Nano,
so let's do that. Let's do that real quick. So let's say you just wanted. Let's say all we wanted was an Nginx container that had VI inside of it. So let's go ahead and install VI. Oops, that was dumb. I probably have to do an update first. So I'm gonna do an apt update. I'm gonna do an apt install. It's probably gonna have to install a bunch of stuff. So I'm installing Vim. So again, I'm doing normal Linux commands, normal bash commands. All right, so I have Vim. I don't even have any aliases installed, but if I do Vim, I now have Vim in this container, right? So check this out. So now let's say I wanted to Vim this default conf. Where are the main site files? User share Nginx HTML. So let's see, Vim /user share. Damn it, I forgot what he said already. User share Nginx HTML. Index.html. Let's mess with this. Let's say welcome to
the party.
And so we say that we mess around, we're trying to figure out how to make our site better. We want to test some changes, so we can log in and we can do that. And we can go here, and that was on port 90.
I think so, yeah.
And welcome, we get some changes here. Welcome to the party, we logged in. These are all going to be the same. So I could actually save this information. So remember I said you could build these containers via Docker file, or you could build them manually. The way that you build them manually is you then have to tag them basically. I always have to remember how to do this because this is not something that people do. You probably shouldn't do it this way. You shouldn't do it this way because if you build containers this way, there's no documentation for what happened. Docker files are really a form of documentation of what goes on, and they're repeatable. This means you no longer have a repeatable method to rebuild this, but you can do it. So we can get out of it. Oh,
so you don't have to restart that Docker container to see those changes.
No.
On the web.
Okay. Well, that's because it was in Nginx. I mean, this was HTML.
Gotcha.
So static file. The next request will get updated. But you can do, what is it? Docker help. Was it tag? I think I run a Docker tag or a Docker. Hold on, I always forget this. I always forget what to do here. Commit. Docker commit. Create a new image from a container changes. Docker commit.
Ooh.
What's up, D1 Mara? Welcome. Thank you for the follow. Docker commit. And then I think you give it the name. Let's just do a help real quick. This is not just not something you should do.
Normally, yeah.
Commit message. So Docker commit options container repository tag. So the container is going to be the one that's running on port 90. So this one. We're gonna grab this and we're gonna go Docker commit. I can give it a message. I think this is what you can do. Added Vim. Then I think I can do this, and I can call it whatever I want. So I'm gonna call it Nginx with Vim.
Beautiful.
All right, and so now if we do Docker images, we now have Nginx with Vim, and it's a little bit bigger because it installed extra packages for us to have Vim installed. Again, you don't do that. Don't do that. That's why I didn't know how to do it anymore, but we figured it out. But you can build these things manually if you'd like. You can you can start with an Ubuntu container. You can log in, install all the stuff that you want. So it may be good for so you could use this for like, if you're still trying to figure something out and you're building out Docker file. No, actually, no, I lied. If you're building out a Docker file and you're trying to like keep them in line, your Docker file should be able to rebuild this in no time. So don't do this.
Though I did want them, I could just put that.
You could put that in the Docker file. So you could do this. You could actually do Vim to get what we just did. Look, man,
exactly.
You could do If you ever want to do something like that, and you wanted to use something like that, you can do from Nginx, and then I would do an update. You usually have to do an update first to update all the stuff, and apt install them. And that will give you essentially the same thing that we just did. That is the preferred method. To do it that way is the preferred method. Really useful explanation. Best one on that. Thank you. Great. Unruffled Panini. I saw that. Yeah. So you can't add it now and pass it to running config. It has to be declared when you build the image. Correct. If I understand your question properly, yes. Yes. What's the command to get in the? Oh yeah, you can pass that along. All right, cool. So we can save that. So what else? I'm trying to think what else with the run command, because tonight we're only supposed to be learning a little bit about running a container. So yeah, building Docker images, running containers. Cool. So a Docker run command. What other? Oh, so you can commit. You've learned how to check your images. See what. The way you see your images is Docker images. The way that you see your running containers is Docker PS. Remember, Docker PS only shows running containers. The way you see all of your containers running and killed or stopped is -A for all. And that shows me all containers that have ever ran that have not been removed from the system. Then we learned that the Docker build command is how we build from a Docker file, how we build an image from a Docker file. We learned how the Docker run command, you run an instance of a container from an image. So you specify an image, runs a container. We learned how to make that run indefinitely. You add in the -D. We learned, and that's the detach mode, but it makes it run like a daemon or daemon. We also learned that you can also map ports. So you can expose a port in your Docker file. So we can expose port 80 for our web servers or port 2049 for MySQL or something. So like, just like that, you could do like, maybe I wanted to install MySQL and I could do Docker pull MySQL. Whoops. And it would go ahead and pull everything I needed. And then I could go ahead and run this and I would have MySQL running. And again, it's isolated from my system. It's not actually installing the stuff on my system, which is kind of nice. You can keep your system pretty clean. It's not all intertwined now. You don't need to do anything like that. But
so when you do a Docker pull MySQL, where is it putting it? Like, where's it
putting it? So it's saving the image to my system.
Yeah.
But it's not installing anything to my system.
Okay.
Everything's contained in here. Docker handles all of that, but it is not installed in my system. Docker is the only thing that gets installed in your system. Okay. These images do get saved there. They do take up space. They absolutely take up space on your computer. Don't like that. Images can be problematic. Yes, images do take up space on your computer. They are still files, so you do need to have space on your computer for them. But it's not actually installed on your computer. And then I could do like a Docker run -D MySQL. Well, this is a dumb example actually, because no one else can, there's no front end for this, and no one is on a remote computer that can connect. But it would allow people to be able to, well, I stopped because it's not set up. But yeah, you can just grab stuff like that. I'm going to show you really quick. So we learned about pull an image. We learned about the Docker Hub. Where you can see these images. So if you want to know, like maybe there's a tool you want to use and you want to know if it's available, like if you can grab it, just search for it. Go to the Docker Hub and search for, there's all kinds of stuff. There's like WordPress, so you can see there's a WordPress image. These are some things are harder to use. Some things rely on more than one container. So that's important to know. But this word, there's like,
so who's actually making these images, these official images? Is it
the official? So usually it's the companies that make the official images, but you can push your images up here for everyone to grab, and you can work with Docker to get those images like authenticated so that they are like the official, the official ones. But you can where. Explore. So you can push all of your stuff here. Again, you have a bunch of stuff. Like there's so much every common Linux application that you can think of is here and available and ready for you to use and to build. So things like, actually, because it's open source, let's talk about sba.gov. I like to, so this website right here, the front end for this website right here is Node and React and a bunch of other stuff. And this is the project that I work on, but it is open source.
Oh, go to mine too.
Is yours open source?
Yes, it is.
For real?
Yeah, man.
Dope. All right, so what happens is I'm going to show you the Docker file. I'm going to show you a Docker file for an entire government, a big government website that helps people run their small businesses, like how simple it kind of is. So this is a whole Node React application. But the Docker file for this, you know what? I lied to you. I completely lied to you. I'm not going to show this to you because this is actually not a Docker container anymore. It used to be. This actually used to be a Docker container, and all this stuff would basically get built into, all this stuff will get copied into a container, into the right place, a Node.js container, and then it will be deployed. It actually doesn't run in a container anymore. It's actually a full serverless application. I forgot about that.
But we do have another one.
All right.
That one.
What is it?
CMS Gov.
CMS Gov?
This is my old project I used to work on. Application written in Go for Fire APIs / BCA. Go to that's it.
Center for Medicare and Medicaid Services.
Keep going down. BCA. Yeah. My old baby.
Right?
That's me. Yeah.
All right, so they have some Docker files. Let's check out some real life. So remember how I told you that Docker files naming convention is weird and kind of backwards, and you get Docker file dot and the descriptor where usually things are like bcda dot Docker file, but pretty interesting. So it's open source.
Beneficiary claims data API.
So let's look at. So they have some different stuff. So they're building different containers for different things.
Yeah.
Let's take a look. I'm assuming this is their main application.
The main one, yeah.
All right, you see how little this is?
Tiny, yeah.
Like, you can get paid a lot of money to write this. I'm so serious. You can write. So ours was smaller than this.
Yeah.
Ours was even smaller than this. And again, they're not all going to be this small. They're not all going to be this small. But you can see that this isn't crazy. Like you can develop this. You can see that it's a from, and they built it from a Golang container, and they're running updates. And they're installing stuff, and they're just running Linux commands, and they're running some Go stuff.
Wasn't it like a mission to keep them like slim though? Don't you want to keep Docker
Yes,
slim?
you do want to keep them slim, small, because that does affect the speed in which they can be deployed at scale. Yeah, you do want to keep them small. But again, you can see, like, to see them be done in real life, like to see this be a legitimate use of a Docker file in real life, like this is always the hard part. It's like, what does this look like when I actually got to build something?
Mm-hmm.
When you actually got to build something, it might just look like this. Again, it can be longer, but
and this is production level.
And this is production level code. Like this, it really is. And that's how nice Docker is. And again, a lot of this comes from you not having to reinvent the wheel. Now, caveats here, security reasons and stuff. You may have to build everything from scratch. But what you can do is you can look at, even if you had to build this from scratch, because why would you want to need to build everything from scratch? You're not in control of this Golang. Like, we're not in control of that, so you don't know what's going to come with that, and changes can be made to that. So your client or your job might require that you build these things manually yourself. Completely fine, because you can go reference their code. Copy the whole thing. Like, I could go all right, Golang 111.5 Alpine. Let's go check this out.
I love that.
Oh, look, I'm already on Golang. That's nice. Official Docker images. Whoops.
Maybe it shows Alpine because it was slimmer.
Yeah, Alpine Slim.
Yeah.
That's fine. But like, Buster. All right, so this is 114. Y'all using 111. Doesn't matter. You can go right here. And you can say, cool, I'm going to start with this. I'll look through it. I'll look through this code, make sure it's safe, make sure I know everything it's doing. But I can literally copy this. I can copy this to start my Docker file, and I can build what I need inside of here. So it's really nice because you don't have to generally, you don't have to do anything crazy. You can utilize other people's code. It's really nice. in that aspect, and you usually just add the little bit that you need over top of it and use it like that. So you can see here in a production level thing, they're only using a couple things. That's why we only went over some of the main ones like work, dir, run, and copy. But yeah, pretty simple. Does anyone have a question so far about these things? Damon, yeah, I say Damon, my friend. It hits a Docker image, so it gives me an excuse to install. Hey, that's dope. I love that our government uses GitHub. Yes, they are. Again, so
they're transitioning.
So Fearless specifically is a cool company because they really are trying to make pretty significant changes. Oh, look at that! Look at Terrence. He made the last update long time ago, though. But no, I'm joking. But generally, try to work with government organizations who are really looking to make a change. That's the only reason why I've been here. I actually vowed to never work for the government again, or like work for a government contractor. But I found a cool company who really was trying to make significant changes, and the government organizations and the projects that we work on are willing to do things like this. That's why these things are open source. All government agencies are not using GitHub or have any open source projects. It's actually pretty cutting edge. Like I said, SBA actually has a fair amount of like open source like Terraform modules, which is really cool actually. Some like very beneficial Terraform modules that our infrastructure teams have written, which have been pretty dope. But you can check out some, Terraform regional WAFs and stuff. So there's all kinds of stuff here.
You guys were using this.
Yeah. Nice. Yeah. This isn't Docker file either. I forgot we migrated most of our stuff off of containers. We actually.
What was the point of that?
I mean, serverless is just. It's better. I know we're going over containers tonight, but serverless is better. I don't care nobody. Everything's not a candidate for serverless. Mm-hmm. But yeah, I didn't know they had this much open source stuff. To be honest. Oh, this is a cool tool. If anyone is doing CloudFormation is notoriously difficult to deal with. This is what we use to deploy our CloudFormation. Kind of nice. Allows you to be able to take a bunch of CloudFormation templates and deploy them all at once, which is really nice. It's not perfect, but it works. Definitely works. We may be safe after all. Yeah, they're trying. They're definitely trying. The command to remove unused images was Docker RMI. It looks like FMMO. Shouted that out. But again, to remove an image, all of the associated containers have to be removed, not just stopped. They have to be removed before you can delete an image. That can be very annoying, but you have to remove the images first before you can delete it. So and make it better. Yeah. Yes, you can do that. You can absolutely do that. And actually, I'll see how much information I can give, or how much if I can create a mock set of data to be able to do this. So the SBA one, like our main front end, it's kind of useless without the data associated with it, which are really these JSON files that are sitting in an S3 bucket that come from Drupal that we create from Drupal. But I'll see I'll see what I'm allowed to do, and I'll see if I can add in some mock data to make it display something, maybe not exactly as is, but so that we can make it better. You can absolutely fork it and submit stuff to it, and I certainly encourage people to do just that, to whatever projects you find that are, if it's open source, if you can get to it and you think you can contribute to it, absolutely go ahead and contribute to it. Just don't look through the history. But yeah,
we did use Docker Compose too.
So Docker Compose is at the beginning of next week.
Okay.
That's container orchestration. So we're just learning the basics of running a single Docker container, and you can see there's a lot that can go into running a single container. There's way more flags that we haven't even introduced yet. But yeah, there's a lot of stuff that comes into running one, and you can see how cumbersome that might be. That's what container orchestration is. It's what happens when you need to deploy tens or hundreds or thousands of these things and manage them. Container orchestration is how you do that. That's why Kubernetes is so nice. That's why Docker Compose is nice. That's why Swarm is nice. That's why all these ECS is nice. Yeah, that's why those things are nice. So what I hope you got so far. Any questions so far? that are about the things that we specifically talked about first, and then I'll open up the floor to anything else. We learned a little bit about what containers are, maybe hard to understand now. And again, I think over the next 2 weeks, it'll put everything into context. We learned about what they are. We learned that they're ephemeral. We learned that that means they can just go away. We learned that they're designed to run a single process. So what we've seen so far tonight is things that are running a single process. We've learned that we've learned some of the basic of commands. We've learned that to run we've learned that to build, to specify an image via code. We can build a Docker file to do that. We learned that to actually build that Docker file into an image, into a container image, we have to build it using the build command. We learned that that image can be used to spin up any number of containers. And to do that, we use the run command. Every time you use the run command, that spins up a single container off of an image. We learned that if you want to run it in the background, you can add a -d flag. We learned that if you want to map ports, first you have to expose that port in the Docker file, and then you have to use the -p flag to sync those things up to be able to use that exposed port and map it to your local machine's port. We learned that you can log into a container if the container has a shell using that exec command, that Docker exec command that we ran. Every container does not have a shell, so you might not be able to log into it. To be honest, that exec command isn't used to log into a container, though. I do want to be clear about that, only because someone showed me it originally and I thought that's what it did. But it's to execute a command, run the command. So I can do other things. I can do Docker exec.
We used it for that.
Yep. So like I can Docker exec this one. So you don't have to log in. You can do things to this without doing it. So I can do a Docker exec ls-la on the home directory. And I run that, and well, this took my home directory, but I can go /home. And I can see what's in /home. Nothing's in /home, but maybe user /share /nginx, I think is the directory. And I can see here an HTML thing, and I can even like nginx HTML /index.html, and I can actually cat this file. So you're basically just passing in a command to be executed. That /bin/bash is executing a shell. So that's why it logs you in basically. But I can cat this file and it spits out that file here. So you can use that exec command to, send a command to this container. We learned that you can check what containers are running. With the Docker PS command, we're used to seeing the PS command for checking our processes. We learned that only shows running containers, but you can use a Docker PS-A to show all both running containers and exited containers. We also learned that you can remove your images by doing Docker RMI, but that to remove an image, all containers associated with that image, both running and stopped, must first be removed. We learned a little bit about Docker layers. Each time you have a new one of those commands, those from or run or copy, workdir, all that creates a new layer, which kind of gets set up and cached as its own little thing. You can use these layers to accelerate your kind of builds and stuff. You'll see that real time. I didn't want to dive too deep into that now. We'll definitely see that soon. Yeah. And again, mess around with it. There are tons. There's so many Docker like run commands, just Docker command line things. What's important to know here is you will in a work setting, you will never do you'll almost never do this. Like what we're doing tonight, the way we're doing things tonight is not how you'll do things. So if you're like, oh man, there's like, I'm never gonna remember that you used like Docker exec /it and the thing and /bin bash. you need to we do need to remember like what we're doing. You know what we're doing, but this is not how you interact with containers. Really, container orchestration next week is how you would really interact with these containers, kind of on a daily basis at work and things like that. But it is good to know these things when you're messing around locally. These things are things you would do as you're trying to build stuff locally. And as even when you're working, as you're trying to work on things on your local machine before figuring out how to like make it on a grander scale, you will be using these commands. But like, it's okay not to be an expert at these like individual Docker run commands. But you do need to understand the paradigms around it because they're isolated. You need to know that you need to expose ports, you need to map those ports to a host machine, and that they don't run kind of in the background by default. So you might need to do that. And you know, there are ways to submit commands to them, things like that. Those higher level concepts are what you need to know, and not necessarily how to do them. And again, you know, when you do that Docker -- help and you get all these options, you can see more stuff. You can see many more things that you could do. You don't need to know all of them. Yeah. I think that's all we need. I think that's all we need to do tonight. I think we got through the main bullet points there. I knew this was going to be a lot because it was a lot last time, and I'm really glad I gave this a second go. I think I tried to add in way more than just this. I think last time we only did 1 day of Docker, 1 day of Kubernetes, I'm pretty sure.
Whoa.
And that was like, it wasn't nearly enough time.
How many hours was that?
No, I think I made it in 2.
Wow, a lot of information.
Yeah, I think I left out a lot. Pretty sure I left out a lot. So,
oh, man.
All right, let's see. I appreciate that. Thank you. Not sure. I wouldn't be surprised if there's a flag for that. If I want to remove all at one time, yes. If you want to remove all the expired, all the exit images at once, there's a couple ways to do this. You can do Docker. I think you can do like purge. No, okay, but usually people will do stuff like this. Docker RM, and then they'll run some type of like an eval statement, or like this comes more into Linux. There's a couple ways to do it. I think you can run like a Docker ps-a. So basically, that didn't work. There's a bunch of different ways you can do it. Let's see. Again, I haven't had to do this in a while. So Docker remove all stopped containers, and they'll give you some options. Oh yeah, there's like PSQ, yeah, PSA. Oh, actually, I think I may be able to just add a -q in here, to be honest. All right, so that's how you can do it. So basically, all I did here was say, hey, go ahead and evaluate Docker ps-aq. And it basically took that and it applied the Docker RM to those things. So that's one way to do it. So
Docker system prune
-a. That makes sense. Yeah. So now if I do a Docker ps-a, I should only see these 3 running containers. And you can see I got an error here. I couldn't remove these because they're running. But I think you can also do like something like that as well. Like with the Docker RM, I think I can do a Docker stop. And it stopped those, and I can remove those as well. There are a couple different ways to do this, and you would be surprised at how fast this stuff can fill up your computer. It's pretty interesting. It's definitely it's like a whole thing. Whoops. Let's see. Amazing. That's a false. That's awesome. So what would have to be in place for Docker to be used then? No, I mean, nothing. All you need for Docker to be used is a server. So we actually used to do this. Once we containerized all our applications, all we did was install Docker. Like, we didn't install anything else. We did an update and we installed Docker on the systems. And then we set up commands that would spin up the containers that we needed. At the time, I lied. At the time we used Chef to spin up containers. It was not a good thing. So you can use things like Ansible to configure containers. That is one way you can do it. not ideal. Well, it's fine. I wouldn't say it's not ideal. It all depends on your use case and what you're allowed to do. But you lose some of the you lose some of the creature comforts of real container orchestrators. But you can use things like Ansible to deploy containers. So that's pretty cool. But you lose some functionality there. Learn from your streams. Awesome. I'm really glad people are getting something that is. People seem to be really excited about Docker. And again, I think it'll make more sense once we dive deeper into building things. Like, I'm glad we spent a day learning the basics. And next time we're actually going to take 3 different common applications that we haven't seen before. We've done a lot with Nginx. We're tired of Nginx. We're taking 3 applications, and they have official images, but we're gonna build them. We're gonna install them on the machine ourselves, and then we are going to work backwards, and we're gonna Dockerize them just to kind of get hands on, and it'll teach us some more things as well. We'll also learn about because these are ephemeral. We'll learn about persisting data. A lot of times you do want to persist data. So data persistence is a thing. We'll learn about Docker volumes and all that stuff as well.
Yeah, we had our databases.
Yep.
That's right. Yeah.
That's weird that you guys were running. Generally, I wouldn't run a database using Docker, but I get it. I get it for sure. There's so many caveats to Docker. Like, it's a really great technology. It is a confusing paradigm. It presents a lot of issues that like you're not used to thinking about. But they've all pretty much been solved at this point, to be honest. So they're great. Where do Docker services come into play with this? Are those items that get developed and defined in Docker files? So that might be more of a question. If I know what you're talking about, then this is more of a orchestrator or Kubernetes paradigm. And yes, and we'll go into more of that. Most of my troubleshooting with Docker, which is minimal, comes from reading Docker service logs. Yes, okay, yes, those are those services. Yes, that is what they are. They're the applications that are defined via the Docker file. Yes. When would Docker be useful, needed? Oh, so Docker is useful or needed. Docker is great for a couple of things. For one, consistent environment. So you can very quickly. So all right. So let's say you start a new project. It used to actually take a little bit of time to like get development environment set up for people in the beginning. Like it would be like, all right. The first week 0, we're figuring out what our tech stack is. So like, we don't even know yet what programming language you're gonna be using and like all this other stuff. And then, so you got to rush to like, once all those things are decided, you got to rush to get an environment set up for the developers to be able to code on. And that takes a little bit of time, and it's like, it blocks people.
Like a week.
It usually takes a while. Also, it becomes problematic because if I set up a development environment for people to use, generally the developers are going to be doing something locally, and now I got to like give them documentation on how to do what I did, and that's going to be hectic, and I'm going to have to spend time helping developers get set up. Somebody's going to have a newer version of Linux installed. Someone's going to have they're going to be running Catalina Mac, and someone else is not. It's going to be running Mojave, and it's going to be a bunch of drama, and I'm trying to get everyone set up, and problems are going to happen. This allows, like, you can much more quickly say, hey, my developers need to develop a Ruby application, a Ruby on Rails application needs to have these things. I can take a little bit of time, set up a Ruby on Rails Docker file, put it in a repo for them. They can take this, they can write their Ruby code, build it with a click of a button, and be able to see these things without having to get their whole environment set up. So that's one thing. 2, scalable services. Docker's used for actually serving these applications. So the same way you would use, like we're using Nginx, a version of Nginx here. I can deploy Nginx containers behind a load balancer to serve those things out, and they can respond to They can respond to requests much faster. They can scale up and scale down as needed. Again, that's the big thing with Kubernetes and things like that. But also they're used a lot for one-off tasks, so one-off processing jobs. So things that just need to maybe every 2 hours your company needs to intake some data from somewhere else, and you may set up a little container to run and like a script, and it'll run and it'll intake some data, transform it, spit it out somewhere else, and die. So it's used a lot for that. And actually, let's see if we can find that thing. Average container runtime graph. It's like this, or maybe it's median, but it looks more like this. Let's see if we can get back to go. All right. So it kind of looks like this. You can see here, it doesn't say what, this is simultaneous containers per host. But actually this graph looks very similar to the one for container runtime. Maybe not runtime. Maybe I'm looking for lifespan. Oh, execution time. It's this one. And you can see here, that's a bad one. But the line's high up here and short afterwards, but time. I don't know. I'll see if I can find it. It was very interesting the first time I saw it. It was very interesting. But basically, again, these things are usually run for seconds.
Looks like this, isn't it?
Yeah, usually run for seconds because they're processing jobs and things like that. People kick off containers to consume a bunch of information and stuff. But also just like they're kind of general purpose, to be honest. The same way that you would run any service, they can add the management of them can add some overhead. I find them to be easier to deal with. But again, when you want to have consistent, especially when you're dealing with things with infrastructure as code, they're great for build tools. So for CI/CD, for running, those jobs, most of the new services are all container based, like Circle CI, Travis CI, all that stuff. But yeah, what's up? There is a bird. Welcome. Thank you for the follow. But yeah, a lot of questions. I mean, there's a lot of use cases for it. A whole lot of use cases for it. Any tips for logging updates remotely with Docker? Great question. And actually, I'll throw that in here as an extra for tonight. If you can see the logs from a container. So, I stopped all of them and I removed all of them. So you cannot. But if we spin up, if we spin up another one really quick, we spin up another one, and we do Docker logs. It's not giving me any logs. Probably not giving me any logs. Maybe I do .logs -f. And I actually hit this endpoint with darn it. I didn't let me map it to something. 80 Docker logs. So you can see logs as long as the container is outputting logs. Let me do Docker logs -f. And I thought that would show me something, but I think if I hit something like, maybe this one by default isn't, but there are, you can definitely check logs that way though. Special logs container. I wonder why it's not spitting out any logs. It's just probably the way this is set up, that container specifically is set up.
There should be some logs though.
Yeah, there should be some logs, but I mean, they probably tell me inside of Docker Hub. But yeah, you can fetch those and you can send them elsewhere. You can also, there's a common paradigm is to send them actually you can send them to the system's syslog. So like my actual host machine syslog, and I can consolidate them there. Most container orchestration technologies like Swarm and stuff and Docker Compose actually handle that for you and set up their own like log groups for that you can kind of move elsewhere. But for logging, remote updates. Generally, for remote updating, your container definitions and stuff, generally I recommend, again, having some type of CI process to do that personally, but it's all just a matter of stuff. I think you can remove via the GUI too. I don't have the GUI installed, but you can. If you have Docker Desktop for Mac or Windows, you can do that. For Linux, you cannot. Looking at Prometheus as suggested, was curious if what you use. So Prometheus is great. We just use all of Amazon stuff for all of stuff. Prometheus is great. You can use Prometheus. We're gonna be doing a little bit with Prometheus later. You can. Prometheus also has a Docker file as well. I've never used Prometheus with containers. I think it'll be interesting. Probably works pretty well. Prometheus is pretty cool. But never done anything with it yet, but I'm sure it'll work. I remember a headache of managing multiple PHP versions locally. Yes, absolutely. Having to manage those versions, Docker really helps with stuff like that. Like not having to care about the setup, like somebody does originally when you're setting the stuff up, but you can manage it all that way, and you can just kind of, I don't know, it's nice. There's a little bit of if you're an experienced dev. It can be a little bit of a burden to your workflow, kind of switching it up because you go from being able to see it real time to having to build it. There are ways to see it real time, but it's a little bit of a hassle to be honest. But it can be a little bit weird. You skipped it, said before container lifespan or something like that. Scrolling down that article. I think that was when I was talking about how long they run for, which is not very long. Containers don't usually, but the average life of containers is actually pretty short. And they get cycled out. Even if a service, let's say your company, when we did used to run containers, SBA.gov needs to be up at all times. Even when it was containers, it would stay up, but those containers would actually get cycled out. We would have maybe 20 containers running, 20 or 30 containers running, and every so often those containers will be, we drop one, bring up a new one. These are security reasons. There's a lot of reasons for this, but that's generally true at a lot of places. But I think that's it for Docker tonight, I think. But what I will tell you really quick is about the bull story.
Yes.
The cow story. Super quick. What's happening on my computer? Did someone hack me? I don't care. So we're talking about cows. Why are we talking about? We're talking about cattle. We're talking about cattle and stuff. So very interesting. I'll try to keep this quick. Very interesting Aaron story. Part of my life. This was actually a significant part of my life. Well, it was a big event at the time. So I may have been 13, 12, maybe 12 or 13, maybe 12, 13 or 14. I don't know. Somewhere in there. Early preteen, early teen. I'll never forget this. Every year, my godmother used to take me and some friends and my mom. We used to all go to Kings Dominion every year, right before school started. In fact, the day before school started, every year.
Ooh.
Sunday, we go out to Kings Dominion. My friend Michael Lawrence. We go. We talked about my friend earlier. Friend Michael Lawrence, his brother. We go off. We come back. Have a great time. We come back. It's dusk. It's pretty dark outside. The sun's down, but it's not all. There's like in the distance. There's some shimmering light in the distance, but like for real, the sun's kind of down.
Yeah.
Now at this time, the house we lived that I grew up in, that was parents to live in, we had a single width driveway, but we had 3 cars. Only 2 cars could fit in it. We had 3 cars. Their house is next to. It's very interesting. When I say this, people think I lived out in the boonies. So I live next to a Pepco power lines field. So my parents' house, a fence, not even a real fence, like a let's see,
Visual.
3 wood beam fence.
Oh.
So like it didn't keep anything out. You can crawl. Yes, this is exactly what we had separating our house from the Pepco power line field. I'm talking about huge power lines, like right next to our house. But a lot of it's a huge field, huge, went miles. But yeah, so it sounds like that. But also literally 100 yards from their houses, 495. If you ever traveled down 495, you've probably seen my parents' house because you can see it from 495. So really weird, houses everywhere. But we pull up. We have a single driveway. We have 3 cars. My brother was a teenager at the time, so he drove. Both my parents drove. So sometimes we get to pull off into the grass to the right of the driveway, which was next to the field. There's a little hill. We pull over. We get out the car, tired, getting ready for the next day.
Yeah.
I look over because I'm about to get out of the car. Bruh, I look up in the field, and all I can see is like the shadow of a cow, well, I didn't know what it was at the time. I thought it was a horse.
Yeah.
I don't know, but it was pretty close. It was probably 30 feet from me, 40 feet from me. And I'm like, Mom, what is this? Like, what is this? And she's like, I don't see anything, because like I said, it's dusk.
Yeah.
She's like, I don't see anything. I was like, Mom, what is that right there? And she was like, oh my gosh, like what is that? She calls inside. We call in the house to my brother and my father. And we're like, yo, it's something out here. You got to come save us, basically, something out here. They come out. They wait a while. They're like, what's out there? What's out there? Trying to figure out what's out there. We're outside. Just come help us. And they come out. My dad comes out with a bat. My brother comes out after him. Like, they're not, I don't know what they thought they were going to do. They're like, what is it? We're like, yo, it's like a bison. It's a bison up on the hill, a horse. I don't know. It's a bison. Come out, whatever. When they get out, it's gone. The thing is gone.
Oh, wow.
Like, it's completely gone. And we're like, yo, what was that? It was super wild, whatever, super weird. They didn't believe us for real, but we were like, yo, it's something there. So we had a dog at the time. We had an English pointer. His name was Rex. Okay. He was a wild boy. He was a wild boy. He actually got onto the beltway. He got under the fence and was like about to run. He was fine. We saved him. We had to catch him through the fence, and my parents had to drive around and pick him up. Super random, whatever. But there was a dog. We had a nice dog house up on the hill. Someone had built it for us. It was like a big wooden dog house, and it was heavy. It was like 70 pounds.
Bro, this is
hold on.
This is crazy to me.
A big wooden dog house. I'm just trying to give you guys some visuals. Okay, so it was like really nice. It wasn't as nice as it was. It was like this, but it was heavy, really heavy, right? So our dog used to use it sometimes. We kept coming out sometimes in the morning, and the dog house would be flipped down the hill. So it was like the dog house was up on the hill. It would be flipped down the hill. We didn't know what was happening. We're like, what? Did the dog sometimes we had to hook the dog up top. They were like, is the dog getting his chain caught underneath?
And then just
pulling over, whatever. Didn't know what was going on. We didn't really think that much of it. I don't know why we didn't. But I'll never forget. This was going on for 2 weeks. My dad is going out to the dog stayed kind of in the fenced in backyard. He's going out to get the dog and to bring the dog in. Yeah. And he's like, he always had to go out there every night. I'm like, yo, bring your stupid ass. Get in the house. Cause that dog was wild. That dog was, we were not equipped. That's why the person gave it to us. A person from a farm gave it to us. They're hunting dogs and they need to just run. We were not equipped to take care of that dog, but we had him till he passed. But we had him. My dad walks out. He sees the dog and he freaks out because he said he saw the dog's eyes. And dog's eyes kind of glow in the dark. So he saw the dog's eyes, and then he looked 5 feet above it and saw some other eyes. And he freaked out, and he came in. He was like, "Hey, there's something out there." We're like, "I told you, I told you there's something out there. I told you something out there." So we're looking out the window. We're trying to figure out what's out there. We're like, "Yo, the dog's gone. The dog got eaten by." We were like, "I don't know what's out there," but no one was going out. Nobody was going to rescue the dog. He was we loved him, but I guess not that much at the time. Super weird. I'm sorry. We're gonna let that dog go, but we're like, hey, he's gone. And then we like checked back, and then the dog came to the door, and like okay, well Rex is fine. Like, what is that? We're looking outside, can't see anything. We get flashlights, look out there, can't see anything. My dad's like, I saw something out there. Cool. He believes us now. Now we start to make the connections. We see the doghouse flipped over to the bottom of the hill all the time. We're like, yo, something's big is doing this, knocking it over. Then one night, like, I know it sounds like a wild story, and it sounds like I'm making this up. It was a full moon. One night there was a full moon. So we finally got to see it. We look up on the hill, full moon. It turns, like, we can see something big on the hill. Can't fully see it. Turns to the side, and you could very clearly see that it was a bull. Like, it was like horns and everything. Like we're like, yo, all right, cool. So we call the cops. We're like, hey, it's a bull. In our, like, we don't know what, like we just feels dangerous. Like, it's a bull in our yard. And they're like, a pit bull? And we're like, bruh, no. A bull, like a cow. They send somebody out. They take 2 hours to come out. Obviously, it's gone. Whatever. Don't know what's happening. I guess the thing started becoming friends with my dog because it started like, we didn't see it, but it started coming more and more in the yard. We started finding cow pies in the yard. So it was pooping in the yard. The like big old cow poops in the yard. Yeah. Like, so like it was getting more, like, obviously it was coming closer and closer to the house. The dog food? I don't know. I don't know. It was hard to get glimpses of it. So then we started to, like, it would never saw it during the day, not a single time. And then so it started coming back in night, and then we started seeing it more, and we would look up there and it would just be up there. And we would like obviously didn't want to hurt the dog, so like the dog would like stay out there and like be like really genuine, like be up on the hill with the bull. Like, it was like weird. We would like watch, and then it would like be gone. And then so one day, so it started getting closer and closer to the house. One night, my dad used to have this old truck that he had parked on the side of the house, and the bull, I don't know what it wanted, but it started butting the truck. Like, it started like hitting the truck up against the side of the house, the fence inside of the house. So it was like, yeah, it was scary. So like, we were always afraid that it was like gonna come through the glass door in the back and just like run there and kill everybody. What's up, Zeke MC? Sorry about this random non-tech story, but we talked about cows in the beginning. We talked about cattle in the beginning. We're talking about this bull story. My dad, I hope he's not watching right now. I know my mom watches sometimes, but my dad goes outside in the middle of the night with a golf club, yells at the bull, chucks a golf club at the bull, nowhere near the bull, shatters my mom's windshield on her van. Shatters it.
You're be kidding me,
I'm not kidding you. Very wild, like shatters it. He was really mad, and then it was like very funny. Like, it's like when you tell people about this, they're not gonna believe this is happening. Shatters the window on the van, like her daily car that she needed. Like, shatters that, whatever, it all gets fixed. So now it's getting more bold. So now we start calling the cops again. We had stopped calling the cops. So we started calling the cops again. And they would come out, they would, same thing every time. Pit bull? No, not a pit bull, yo. It is a bull, it's a cow. There's a bull out here with horns, like, come get it. And they would show up, and they would never see it until one night. Yeah. The one night. Actually, we stopped calling them, and they stopped tripping about it. It actually came down during the day and scared a dude. No. That was after actually. No, we called the cops. Very funny. Very funny. The first black cop we had gotten, the very first black cop, all the other cops just walked up in the field with their flashlights. We're like, "It's a bull up there," and he was like, "They were just like, where?" And they just walk up there with a flashlight. The first black cop we got. He comes, we're like, yo, it's a bull up there. He's like, oh. He's like, well, I'm not equiped to do this. So he calls animal control.
That's what I'm thinking.
Yeah, and so while animal control's on the way, he takes a couple steps up and like shines his light up, and sure enough, he sees it and he gets back. He's like, oh, we need backup. He's like, that's a whole bull. I was like, we told you it's a bull. Like, it's a full bull out here. And oh my God. And so the bull, he finally sees it. So now they believe us. So now they start bringing animal control out. And animal control during the day, they travel down the field. They searched, they like checked all the local farms and stuff. And the farms, I don't live near many farms.
Bull?
And so they're like, they didn't want to lose a bull. Like, couldn't find out where it was. Like a full grown bull. Nobody claimed it. Whatever. When I tell you, these people brought out. I know this sounds crazy. They brought out. This sounds like a fake. I'm not. I have documentation for this. I think we have document. I think my parents have some documentation on this. They brought out an animal whisperer from like Tennessee or Mississippi. I'm not joking. And I'll never forget her. We told her not to she came to help. She had the dog. We're like, yo, if you let the dog go, he's gone. Like, he ain't coming back till the morning. So like, don't let him go. Yeah. And she was like, I'll be fine. Like, I'll get him. She's let the dog go. We're like, all right, well, you gotta go get the dog. Like, I don't know. You gotta get the dog. Walks up into the field in the middle of the night by herself. Walks up into the field, comes back. After a while, it was like, she was like, yeah, the bull, like it's scared. It's like comes from a like abused home.
What?
And we're like, did you see it? And like, no, it was wild. It was, everything about it was out of control. Like,
It's an amazing story.
I'm serious. I'm gonna get my parents to come on here one day.
Did
and my
she
brother.
See the bull? Did she actually see it?
I guess so. I don't know. But what they try to do is it came down one day into the street. There's a guy next door, and he was in his car like cleaning it out. And he turned, and the bull was in the middle of the street, like staring at him. And he had to like back out down the street. So that actually made it to the newspaper. Like finally, we've been talking about this bull. This guy almost like the bull like kind of trots and chases him down the street, his car down the street. So it gets in like a little blurb, gets in the newspaper. The animal control is like, all right, we gotta do something about this. They set up a corral. They set up a big corral inside of the Pepco field. They had people stay out there at night with like big old spotlights. And so they got the bull to come into this thing with hay and stuff. They got it in there. It was like a little temporary corral. They trapped it one night and they were gonna try to move it. And that joint broke the whole corral down. It like broke the whole thing down and ran off back into the field. Then winter came. We didn't see it no more. It stopped coming for the whole winter. Yeah. We're like, it died. Like, I don't know. Nope. As soon as it got warm again, bull starts coming back. Because it had chased somebody, they were like, we got to do something. Yeah. They brought in the SWAT team.
No, they did not.
They brought in a SWAT team. I know it's a sad end to the story. We had given the bull a name. The bull's name was Emily.
This is so sad.
They brought a SWAT team. Bull's name was Emily. Well, we called the bull Emily, even though it was a boy. my dad named it Emily before we got to see the full thing, and they
no, they didn't.
They brought in a backhoe and buried it because they didn't want animal rights. I mean, I might have just told on them, and now this might start a thing. But like,
they did it very.
They killed it. They said they had to because it had like chased somebody.
Trying to attack somebody.
Yeah. So that is my.
That is an epic
rip. I'll bring them in. I have pictures of. They took pictures. I don't know why they did this, but they took pictures of us for us of the dead cow. And I remember, this part. I didn't embellish any of that story. This part might be embellishment a little bit. I remember because it happened in the middle of the night. I remember like them like calling my dad, and like the phone ringing like super late at night, and my dad answering it and was like, "Hello," and they'd be like, "Okay," and I imagine they were like, "It's done." It's done. Like it's done. Like that part might not have happened. But like they definitely called him. Was like, it's like, hey, it's done. Yeah, okay. But yeah, just interesting. We're talking about cattle. Interesting bull story.
The SWAT team seems like overkill, man.
Yeah. I mean,
terrorists. This is ridiculous.
Yeah. So we were talking about cattle. I'm sorry, Zeke. Welcome to the channel, man. We just did a bunch of Docker stuff, but we were talking about cattle earlier, and I told people I had a bull story, so I'm giving them the bull story. And I wonder.
Poor Emily, bro.
Poor Emily. Yo, it was amazing times in my life. Like that was like that whole thing sounded like it was a couple of days. That was over a year. That was over a year. It was a saga. Had a bull story. Hey, I'm telling you, all that's facts. All that's real. And if you guys like, I live in PG County. I grew up in PG County, Prince George's County. Like I live less than a mile from a major metro station. I didn't live.
You lived in the boonies.
I did not live in the boonies at all. Like literally at all. Like I lived 100 feet from.
I say loose bull in PG County.
Yeah, will that come out? That's interesting.
No, SWAT team. It's a cover up. It's a conspiracy at this point. Oh, if this comes up.
No, Pitbull stuff's gonna come up. Well, I don't want to type in my address, but I'm gonna bring y'all something just to confirm my story, just so you guys don't.
What year was this? 2014?
Nah, that was way before that.
Okay.
This might have been 2003, 2004, 2003. But yeah, cool. Hopefully you guys enjoyed that. That was all extra. I should have let everyone know that they could leave after that they could leave after the Docker stuff. But yeah, tonight I'm gonna get the rest of all the last week's stuff up into YouTube. So if you're waiting on that, everything you can catch up on everything in YouTube. But that's all I got for you tonight. Next time, tomorrow, there'll be the camera won't be in this weird spot. We'll also not be doing this weird like 2 computers thing. Like I'll have it all fixed up again, but again, the setup's working out, but gotta work it all the way through. Actually, maybe we'll have to leave it like this because we're actually moving into a new room. Yes. Moving into a new room this week, a little bit larger. So we might actually have a better setup next time you hop on. Maybe tomorrow. If I have time, I'm gonna do it tomorrow, but probably not till after. But yeah, so great question. So unfortunately I had to not stream last Wednesday. Everything got pushed back a week. So we'll be doing object-oriented programming inside with Python tomorrow. We'll be doing the part 2. I also realized that we rushed through some things and I actually forgot to do the 4th pillar of object-oriented programming. So we'll go over some polymorphism and we'll just get through some practice. And then we'll do some algorithms using object-oriented programming concepts on Wednesday. So yes, we will be doing that. It actually makes things actually pretty great because before, when we did the projects, we were going to start projects on Wednesday and finish them on the following Monday, which isn't very, like, that seems a little broken. Yeah. So now this way we'll actually start our project, like next week, we'll start a project on Monday and we'll finish it on Wednesday, which I think is a lot nicer, including the next week to finish out kind of the main pieces of that. So yeah. Python's my best language. Yeah, Python's great. I'm getting better at it. Go is definitely my best language. I prefer Go, but I do like Python a lot. And as I've been using it more and more lately, I'm having a good time with it for sure. Great question. We were supposed to already start 100 Days of Code, to be honest. But I think now that we know some object-oriented programming, I think it might be a prime time to start. Yeah, maybe this week will be a prime time to start. Maybe that's what we'll do. Maybe we'll try to. Yeah, maybe we'll start. We'll start next week to give everyone a little bit of mental time to ramp up. Okay. We'll start on Monday of next week. Okay. We'll start 100 Days of Code. I like that. So it'll carry us through it'll carry us through a while, but I think that's a good idea. I like that. Thanks for bringing that back up. So we'll put out some social media stuff about that as well. No. So Monday we'll start 100 Days of Code Monday. And we'll try to have some like things to guide people along, like every 10 days or something, give people some stuff they might want to try in the next 10 days. Okay. But I like that. I'm going to participate, but I'm going to participate in some obscure language. Like
something you never did before?
Yeah, like maybe like
Rust.
I'm doing Rust. All right, cool. I like that. I'm going to do Rust. I'm going to participate and I'm going to use Rust. But cool. That's it for tonight. Thanks everybody for sticking around. Thank you for listening to my bull story, which is it's not a BS story. It's a real cow story. But yeah, hope everyone got something out of that tonight. See you all tomorrow for a little bit of Python. And then we'll be back here on Tuesday to learn some more. We'll dive deeper into Docker. So cover what we went over tonight, kind of just read through, see if you can pick that stuff up, see if you can learn some of the terminology that we talked about, because we'll be diving a lot deeper on Tuesday. But that's it. I'll see everybody later. Have a good night.
See you guys.
Peace.